Well, hello there. Hi, and welcome. It's time for SkyTour LiveStream West. The Arizona Observatory is up and running, as you can see, and we are tentatively hoping that the telescope will behave tonight. As you saw the other night, if you were with us, the telescope misbehaved, and now we're doing things a little bit differently, trying to make it so that it won't misbehave. And to keep me in line, keep me from misbehaving, I have with me Daryl Mason. Daryl, what's up?
Hi, Mark. Darn tootin'.
Yeah, I know, right? Yeah. So,
hello, everybody.
Yeah, say your highs, man. Say there's a lot of people here already hanging out with us.
Howdy, everybody.
Yeah. I see PG is here, Papa Tom, Marianne is here, Tara's here, Genghis is here. Hi, guys. How you doing? And we have Taryn. How you doing, Taryn? Taryn Marie. Welcome to SkyTour LiveStream West. This is the what's happening? We are in the Arizona Observatory now. Not in the observatory. I'm in Connecticut, 2,500 miles away from this thing here that's running, and trying my best to get it all operational and robust and bulletproof, I guess you would call it. But you know what? And Marianne has said this often, because Marianne is our one of the people that's very fundamental to making SkyTour West work. And Tara's out there too. But Marianne said, that, and she says the right thing. There are hiccups with new technology, and things don't always go right. But when they go right, it's worth all the reward that you get. And you'll see tonight, hopefully, where we go, you're going to see some amazing sights, hopefully. I'm going to try to bring you some things. Daryl has some great ideas. He has unbelievable font of knowledge in his head. I have a font of somewhat useless knowledge in my head. But, between us, we will help you have a really good evening and a good night.
Hey, I'm a regular Cliff Clavin.
Hey, there, I gotta tell you there, Normie, that guy, right?
That guy.
Cliff Clavin. Yeah. So, in this image we see right here, this is a test image that I just drove the telescope to. We're going to actually drive the telescope to the different things we want to see tonight. Just move it by hand, manually. Because one of the glitches we have in the technology right now is that if we tell it to robotically go to these things, it can sometimes get confused, and then that ends everybody's night. I'd rather show you all kinds of things, kind of do it a little more kludgy to show you the really cool stuff, and then we'll attempt maybe near the end of the night to actually do what's called a go-to. Okay, and that means having the telescope just drive itself to objects that we state. It does that so well, it has for so long, but this is all new technology. This is a whole new world, and so we're trying to make it work the way it should. The only thing I'm going to do right now is I'm going to let me hang on there. Just one second, guys. I'm trying to...
Kludgy.
Huh?
Kludgy. I used to work on those things.
Yeah, it is kind of kludgy at times, right? Sorry about the Firefox icon right there. You're actually seeing my screen behind me here in the observatory. I can actually move that out of the way like that. So now I am going to be all alone on the screen. Yay! And I'll move this over here. And that's the desktop on the computer out in the observatory. This is the ops cam, the cam that shows everything that's going on in the control bunker here. And it's kind of funny. I can't get over the fact. I guess I gotta just get over it. I can't get over the fact that this telescope that we're running is over 2,400 and change miles away from me right now, out in the Arizona desert, in the middle of nowhere. And by the way, if you haven't heard, it's off the grid completely. There is no, it's a green, I should say. It's a green observatory. The power comes from the sun through solar panels that store energy all day long, so it can run all night long. And the place is just, it's amazing. It's really crazy. Now, it comes with its risks. When I was out there last time, I definitely, didn't follow the advice of people. I thought that I was beyond getting heat stroke. I thought the temperature being only 105, that's nothing. I love the heat, and I do. But my mind was ready for Arizona, but my body was not. And so I ended up in the hospital taking several liters of fluid in an hour. And I want to credit Marianne Robb, who's in the chat right now. She is a police officer, been in law enforcement for many, many years. And she recognized this idiot who was going down fast. And she said, "You're going to the emergency room." I said, "Why?" When I got to the emergency room, the doctor said, "Good thing you came." So I have to say that, I'm obviously indebted to her for taking care of making sure that I survived. So I am forever indebted to her. So she's out there, so show her some love. And look, it's Daisy and Zoe Amethyst. Yep, Daryl.
I said, "Yay, Marianne."
That's right. She was...
I read a story just this morning about a woman from Massachusetts who was out in the Arizona desert and she died. She went out there to meet some guy on a Tinder or something, and they went for a hike in the desert, and they got separated, and she didn't drink enough water, and she died.
Yeah, but she was actually... He was a doctor.
I thought he was a cop.
Or wait, so you're right. He was a police officer. He should have known. You're right. He should have known. That's really crazy.
Anyway, drink more Ovaltine.
You know what? I'm drinking more of everything. Okay, I've got my grape flavored water here, and it's because I'm using a telescope in the desert. So I feel like I need to drink more anyway. So, and you folks, let me know when you need a bathroom break because we're going to town tonight. I hope. And by the way, for you that just joining us, this is the new screen. This is the control system for the telescope you're familiar with. But this is the all-new system for running the telescope with this system. And we have the ability to do instant processing, so you can see things that the telescope is doing. You can see very faint data that the telescope is going to show us. And it's actually a process by which we will be able to process our images on the fly. And you will see these images just exactly the way the telescope would show them to you. In other words, they're going to be processed right here in front of you. It's a whole different world. You can see by all the controls, it's a little bit more complex than what we had last time, and it's taken a while to get used to it. Our camera controls are right here, and the camera we're using is a dedicated astronomy camera. It's about yay big, and it sits on the front of the telescope, and it's actually a system that uses what's called a cooler, and the sensor has to be cooled. So I have the target temperature at minus 10 Celsius right now, and it started at 34 degrees Celsius. So that's over 90 degrees, by the way. And right now it's at minus 5 Celsius. All right. So it's below freezing right now. And the sensor. The cooler the sensor is, the better electricity flows, but the less noise that we get from the process that's involved in taking images. All right. So I'm going to go over here. This is where we set our exposure up here. And this whole process is going to be sped up by about, I'd say, 4 to 6 times soon, because we're actually ordered and we're going to have Starlink at this site. So we're going to have the Starlink satellites that are going to bring us, much, much faster capability, 20 times faster, actually. Than what we have right now, so it'll be effectively real time, and that's going to be cool. I'm going to drop off the stack, and when we do this, we stop the stack, you'll see that the image starts to go, it gets larger, and that's very important. Okay, so now the last thing in the puzzle is this. This is our planetarium system that we have. right now we're on the star Antares, and that's that red star right over here that you just saw. And right next to it, to its right side, right, you saw something else. That something else is actually a globular cluster. It's called the Crab globular, but it's a globular cluster. It's well, it's like an exploding snowball of tens of thousands of stars. And that's what we saw. We saw Antares, and we saw that. And it's really pretty. It looks really, really pretty, you know. Right up here, right above it, we're going to head to that. That's another nebula. That's actually a nebula that's really, really pretty. And we're going to check that out. First things first, I'm going to just bring up my telescope control. And I'm going to make sure that we got that. And now what I'm going to do is, this is a recent addition thanks to Tara, who went out there and put it in. Tara, you can see how well it works. I don't think there's any reason to change how it works. It's working fine. We can actually see what the telescope thinks it's doing. Very important stuff. And the last thing I want to do actually is I want to have the telescope view right here. I'm going to move it over here. So this is going to be kind of in the way, I'm sure, but we'll look at it as we need it now and then. Okay, so what I'm going to do now is I'm going to change the speed at which we're moving the telescope, because I'm moving it by hand tonight until I troubleshoot the issue. So I'm going to go to slightly less than the maximum speed, and that means going to 1.5 degrees per second, right? And then I can minimize this. And now our telescope, you can see down here it says scope. That's where the telescope is sitting. So now what I'm going to do is move it up north and then move it over to this spot here, Rho Ophiuchi. And there goes Antares. You can see it heading out now as the telescope moves up. And over here, you can actually watch the telescope moving up in this little view right over my head here. And see, it's eye candy. We got eye candy for everybody. And right there is what we're looking for. And I went a little too far. Let me just back up. That spot, those 3 stars that are right here are the ones we're looking for. And I'm going to just make sure. Okay, let's do this. Yeah, and I'm gonna move us down to now slower. 1/4 degree per second. I think it was 0.25 degrees. And now what I'll do is I'll move us down. And you'll see those stars right there starting to move up. These are being updated every second, okay? So that's what's happening now. It's being updated every second. So that's why there's a little bit of a delay. And that's actually kind of cool, actually. All right, and then I'm going to head to the west a little bit and bring that over. I'll get rid of the planetarium thing here in a second. Okay. Excuse me. All right, I'm just going to head up a little bit more. I'm going to go south a little bit more. That's good. Okay, so this is a star called Rho Ophiuchi. It's a star in the constellation of Ophiuchus, but it's right near Scorpius. Okay, and Ophiuchus is a fairly large constellation, but doesn't really look like what it's supposed to be. Scorpius, the Scorpion, is one of the constellations that sort of looks like what it's supposed to be. And what we've done is we're kind of right here. And what I might do is try to synchronize the telescope again here. But that's what we want to see. So what I'm going to do is come in here And what looks like 3 little stars with another couple little stars down here, you'll notice in a second, is actually a lot more than that. So what we're going to do is we're going to do 25 seconds, and then we're going to actually we're going to live stack this. And you will actually see in the live stack, it's going to probably show you the Antares shot because it stores the last shot. So I have to clear that. Right? And now in the next shot, you'll actually see what the telescope sees. So we're counting down. Here's the bar down here. As the bar progresses, when it's fully green, the first shot comes in. And over here, since we're stacking, this is live stacking now. All right, you'll see the first shot. There it is. Okay. And so it says frame stacked only 1. So we're going to let a maximum of 2 come in first. So that's another 25 seconds. And I can probably just move this over a little. There we go. And when the second one comes in, then we can actually try some processing setups on here. You need a minimum of 2. Oh, and we got a satellite coming through.
That's the second one tonight.
Yep. Okay, this is a little bit quick, but you can see that we have lots of nebulous detail in here. All right, that's hiding behind this normal exposure. Okay. And let's try this other one. Same, okay. Yeah, there's a lot there. And it looks like that might be the... Could that be the tumbling satellite that's going to show up again in a few minutes? Or a few seconds?
Maybe.
That's kind of funny. It's sort of the same angle, same location.
Yeah.
The same star. Yeah, there we go. Alright, so down here I can make some adjustments to our data. Yeah, and let's see. So now we've stacked 5 of them. Let's see if this will do something for us. Okay, and let's see if we auto color. What does that do? Yeah, that's wrong. Let me undo that.
Cool.
Yeah, it looks cool, but it's not right? So we want to reduce the blue, so I can individually reduce the blue on here to get it more toward what it actually is. And that's not what it actually is. Yeah, this is not exactly what I wanted. What about this? Yeah, that's more like it.
So that satellite does look like the one the other night.
Right. Looks like it's tumbling again, doesn't it? That's pretty crazy.
And I think we thought it crossed over the Terminator into night.
That's right. But look at that. So this is something interesting, guys. Here's a satellite going, okay, it's heading toward, it's heading to the east, right? Heading from the west, which is to the right, and heading to the east. And it's not a regular satellite. It's probably a rocket body, and it's tumbling. So you see that its brightness begins to dim, and then it goes almost out, and then the brightness comes back, and then the exposure stops. That's why it looks like it cuts off. But it's also, it's in here, and it's actually crossing Rho Ophiuchi directly. Now here's the thing. Look at this shot, all right? This is showing you what you would see only after in the past that I would have done the processing. But we're seeing it now, just like you'd see it when it was processed. You're seeing it with your eye, just like it really looks. Over here on the left, there's a dark cloud here. That's actually a dark cloud of dust out there. There's a dark filamentary structure here, several here off this star. Look at them all. This is incredible. And we can actually do some filters here, or enhancements. So for instance, I can actually sharpen this thing and make it look a little bit more intriguing, and let's see if I could get this to work like this. Yeah, look at how sharp. Look at this. Look at these clouds now. Look at that. Here's what's interesting about these guys. See these little things over here? This one right here and this one right here. You notice how they're rounded at the bottom? That's because the stellar winds that are pushing that black dark dust, which is most likely carbon molecules, toward the back side here, are creating, this is like a shock front where the stellar winds are striking this dark dust and streaming it back. It takes hundreds of thousands, millions of years for this process to occur. But check it out. Isn't that crazy? I think that's pretty cool. I really do think that's really cool. Wow. And you can see in here, you can see there's a... And by the way, this type of nebula, these are reflection nebulae down here. That is to say, dust that's actually taking the light and scattering it. All right? And by scattering the light, it scatters the high energy light first, which tends to be the bluer light. So they look like white or blue when you look at a reflection nebula. And look, you can see little subtle edges here. These are things that'd be completely lost if it wasn't for being able to do this. You know, completely lost.
I can still see that satellite trail.
I see it here. I see it here.
It did get dim, yeah. It's heading toward the upper left.
Yeah, it's in the Terminator. There's no doubt about it. It's crossed over. It has crossed over to the other side, young Skywalker. So what do you guys think of that, huh? This is the Rho Ophiuchi. Now, Rho is R-H-O. It's the Greek letter. You know, in the Greek alphabet, you have alpha, beta, gamma, delta, epsilon, zeta, eta, theta. I can do the whole alphabet, but that's because I'm an astronomer. We do that. And Rho is a designation for a star. And Ophiuchi is the name of the constellation, but, you know, abbreviated for our discussion of the stars. It's Ophiuchus, so Ophiuchi. Or Ophiuchi. People call that an Ophiuchus. So Ophiuchus is a cumbersome name for constellation, sorry.
I call it Ophiuchus.
Yeah, and most people do. I called it Ophiuchus years ago. And by the way, just so you know, if you look down here on the left, see that number? We have stacked, as we've been talking, 16, now 17 frames. So what that does is that makes these subtle details much more visible. Much more visible. And I think that's pretty cool. I do.
Mark, Genghis has a question. Can
Sure.
you see it, or would you like me to pass it on?
I'm looking. I'm seeing him. Hey, Keith, how you doing from PK? I see he's here. And Genghis. Can you... Oh, I see what you're saying. Yeah, that's an interesting question, Genghis. You know what? He's asking, what do we do about the filters? Can we change them out and stuff? I actually have a filter that's meant for looking at nebulae and stuff in there right now. And for those, you know, I just can't get over this region. I've never seen this, guys. I've never seen this in my life until I started looking at it with the SkyTour LiveStream West. It's a stunning region. Look at the oranges. Look at the blues. It does have blue and orange. This is actually true colors. It's really, really pretty. Yes, Isabella, there's many, many, many colors. I'm a little bit closer to giving you guys access to a generic server online, so you can go and grab all these photos for yourself, both the stacks, the individual photos, the process shots like this one. Those are all going to be made available to you as well. And I almost had that ready today, but it wasn't quite ready. But the process I do is I save this just as you see it here, okay? And then I save the stack so that you can take the individual images that are already stacked for you and then process them so you don't have to do the stacking. I also have all the separate images too, but they're up there. So if you want to take them, you can take them, but I'm only saving the stack. I'm not saving all the individual images. You know? I don't know if I answered Gingus's question yet. how do I get multiple lens filters in here? Like what he's talking about, like is the nebula filter, like an O3 filter, an H alpha filter. I have a generic filter in there now that does the sort of the best of both worlds. And I can't use what we had here, which is a filter wheel. In fact, the filter wheel is right behind me. That's going to go in this telescope here when we put it back in the new building here. But this is a system that is sitting right off the front of the telescope. So we don't have the real estate to try and do that. And I think that wasn't intentional. That should not be there. That's a mistake. Okay, let me just get that out there. Okay. I'll show you what I mean. So when you come in here, I think I might have a photo to show you. Something that'll make sense for you. Meanwhile, we're still stacking. We're up to 24 images, by the way, that we've stacked. Interestingly, when you stack the images, you'll find that as you stack, the color becomes richer as well. But you have to also have an exposure that's long enough. If I took shorter exposures and I stacked them, yeah, we'd still see the nebula, but it would look almost black and white. You wouldn't see the color. The color comes with the density of the photons hitting the sensor. And if you don't have that density hitting the sensor, you're not going to get enough photons to give you color. Well, that's sad but true, I guess, you know. All right, let me look for something here for a second. Talk amongst yourselves. I'm going to find something. I think it's in here. Here, it's under here, I think. I know it's under here. Yes. Okay, I'm gonna show you a picture of the system. Let's see if I can. I want to see if I can show this. Yeah. Okay, so here is the telescope. Okay, this is the telescope in the dome. Okay. And you can see that this has this thing on it, and then it's got this thing on it. That's the astronomical camera, the dedicated camera. For those that are aficionados of these cameras, that's a ZWO ASI 294 MC Pro. And that is hooked into a lens system on the front of the corrector plate of the Schmidt-Cassegrain telescope. That lens system and this camera are replacing what would be a mirror, because what happens is light would enter here, go down to the bottom of the tube, bounce off the main mirror down here, bounce up here to the secondary mirror, and then bounce back down and go through a hole at the back end of the mirror and out to an eyepiece or a camera. Well, I removed that secondary mirror and placed this lens in its place, and it goes to the camera. This lens increases the capability of the telescope by 25%. Okay, actually 25 times, my mistake, the capability. And that gives us a lot more reach, a lot more capability. It increases the size of the field to about 2 degrees, and it's really just a very, very nice camera.
Low power wide field. It's a F2 now instead of F8, correct?
That's correct. You know, if you heard of camera systems, this telescope operated originally at a F number of 8, so F8. But this here dropped it down to F2. Now, if you think about it, camera lenses that are F2 are very expensive. You know, and if you bought usually it's like you buy an f2.8 lens, it's a gigantic piece of glass. Well, this is a gigantic piece of glass. All right, and thanks to you know, the generous people that wanted to see this public outreach, and to Marianne Robb, who is, you know, helping us with all of these things, this is a reality now. You know, Marianne has actually been instrumental. She, you know, I've never seen anyone, I know I keep saying this, but I've never seen anyone work harder. And she's I don't know, Tara's right up there too. Tara Diulis, who was in the chat, she's also quite a hard worker. I can't fault her. I had to practically kick her out of the building the other day because she kept staying in there. It was over 103 degrees, and she still wants to do more work in there. And it's like, you know, I'm telling you, those people, I can't say enough for them. Can't say enough about them. You know, but anyway, so that's that. And wonderful, wonderful, wonderful people. And all the contributors that contributed to the GoFundMe to make this all happen. You have no idea. I mean, that's why I'm doing this. I'm doing this all for you. You know? You know? Oh, Keith says, well, each tracking stay. What do you say? Mark Cam looks way better tonight. Not so glitchy from the chroma key. Yes, that's correct. And okay, what he's talking about is the fake pseudo green screen. Like when I actually move around here, and then he says I retract that stay because he actually saw it glitch. The camera here that I'm using, I allow myself to be transparent so I can point to things like this. Like if I want to point out this star to you, I can point out this star, you know, and say, hey, look at that cool star. Or if I want to come over and say, hey, this is this complex right here. Look at these beautiful tendrils of black right there. It's all a matter of the lighting that you put on yourself. I only have one light on me right now. The other, if I put the lights on behind me in my office, that confuses the camera, you know. Oh, look at this, Daryl. I think this is better than, I think this is actually far better than what we have done in the past.
Uh-huh.
I think so. You know?
You have a lot more images stacked.
Yeah, I did 38 images here at 25 seconds. That's quite a lot. You know, and if I did it the old way, it would have taken a lot longer. And this way, it doesn't. So what I'm going to do is I am going to pause this stack right now, because I think 38 images is quite enough. All right. So we're going to pause, and I'm going to save this stack for people to process if they wish. And then I'm going to save exactly what you see on the screen. This is a processed image that I processed in here, in this program here that you're watching. All right, and so that is going to be that with the Rho Ophiuchi complex. Nice. I'm beside myself with how well this performs. I can't tell you. It's amazing. All right, now let's come out of here and let's go somewhere else. Yeah, I gotta quit this here. Hold on. I also have to clear that stack. I have to clear that stack because we're going to be taking images of something else. You know? So that's what we're going to do. But the Rho Ophiuchi complex is really just an incredible location of dust and all kinds of, you know, stellar debris, basically. You know? Oh, okay, here, this is actually a good image. This is a 25-second image. This is what it looks like without stacking it. See, this is the raw image. Look at all the noise. See all that noise in there? You know? That's pretty bad. And when you look at that noise, it shows you what you can expect. You know? And by stacking it, you get rid of a lot of that noise. And that's what we did here, was to get rid of that noise. So we're going to drop this down to 1 second exposures as we hunt down our next object. And if anybody has any questions, I'm happy to take them, and Daryl can, of course, answer them as well. First, I want to say hi to Davey Dreamer and say hi to, I said hi to her. And then we have Corey Williams. How you doing, Corey? I actually looked at Saturn last night, Corey, with the telescope, and this camera is actually too overpowering for it. I could probably figure out a way to take it at a much faster shot, you know, but This is a dedicated astronomy camera meant for deep sky objects, and so looking at planets didn't really work out so well yesterday when I looked at Saturn. I didn't tell you that, Daryl. I looked at Saturn yesterday and it was all overexposed. But no big deal.
Yeah.
Hey, Bobby Burgess, what's going on?
Well, it's a low-power wide-field telescope now, and
Yeah.
meant for catching cosmic vistas, and you want narrow-field high-power for looking at planets.
Right.
Saturn has just passed opposition, folks, and if you can get a look at it a few days to either side of opposition, the rings are especially bright now.
Oh, yeah.
Because sort of like the opposition effect on a full moon, the light is shining from the rings directly back at us, and so they look extra bright.
Yeah.
They'll do that for maybe a week on either side of opposition. We get a clear sky here. I'm going to try to drag one of the scopes out.
I would hope you would.
Old trusty 8-inch again.
Yeah. I think that's a good idea.
That's a planetary scope anyway.
Yeah. Okay. So what I'm going to do now is I'm going to... That's going to go right behind my head where it shouldn't be, so I'm going to put it over here. Actually, I can put it down here. I'll park this down here so you see what the scope sees. That's actually a red light, red lit screen, and we'll make it red eventually because right now we have the low light on. Okay, now just to back out a bit and show you kind of where we are. We were just over here, and the Milky Way is right here. All right, so the Milky Way is to our east a little bit, and there's a lot of things to see in the Milky Way, as you can see. And we're going to head over and start checking out some of them. I know you're saying shut up and just do it. Yeah, I am. I'm gonna. I promise. But the first thing we're going to do is I'm going to set up to go faster and move the telescope faster, because otherwise it'll take a long time to get over there. And then I'm going to head toward the east. And
Did we show them the small Sagittarius cloud the other night?
Maybe.
I don't remember. The one with the dark cloud in it?
Yeah.
That kind of rings a bell.
Yeah, I think so, but we'll get back to it. What I'm going to do is I'm going to bring you over to a real eye popper of an object. Interesting. You can see the stars changing because I have a 1 second exposure going on right there. Actually, I might be able to do something a little more interesting here. Maybe if I do this. Yeah. Now even though it's got a blue cast to it, you'll be able to see way more of the stars that are coming through, and I think that will be really, really cool. All right, so let's do this. Okay, now we're gonna head east again. You'll watch the stars streak. Okay. Oh yeah. See, we're getting into some Milky Way over here. Galaxy of 100 billion plus stars, maybe. Well, as possibly as many as 400 billion, but I don't know for sure how many there are. Nobody does. None of us knows. None of us knows the answer. Okay. Now we're gonna go a little slower. Slow down as we pull into this nebular territory. Doing it this way is what we have to do, because we're still testing the system. Okay. See, alignment is good tonight, Daryl. Look at that. What's that?
So far.
Yeah.
Knock on wood.
Yeah. Knock on Formica. Yeah. Okay.
Knock on my thick head.
Now we don't need knock on my thick head, yeah. So let's undo that real wacky setup. Actually, bring it back for 1 second. So let's really push everything. So now let me just move this down a little bit. As I say, move it up in the sky, moving the telescope down to center this. And then we'll talk about this. Okay, now we head east a little bit. I'm going to put it to the right edge of the frame, but you'll see why in a minute. I think you already see why. But even more. Okay, this is an object we call the Lagoon Nebula. Messier 8, the 8th object on Charles Messier's list of objects not to be confused with comets, which is what he did. Kind of cool, but that's what this is. And what I'll do now is I'll go back to a 25-second exposure with this, and well, that's 35, but it'll still work. I want to just do it, keep it all consistent. 25 seconds. All right, and now we'll actually live stack this. And I'm going to clear the previous stack. Sorry if you're watching this on a larger TV and I just blew out your screens. I apologize. Okay. And now we'll undo all the processing and let it. This isn't undone yet. This has to be undone. Yeah. Oh, yeah. Okay. Well, what do you think of that? Look at that. Wow. Look at these dark globules over here, you know, known as Bach globules. Bart J. Bach is the guy that discovered those. He discovered those are a place where stars are forming and planetary systems, as it turns out. These dark globules that you see are self-condensing clouds of dust and gas. Self-condensing clouds, of course, are the foundation for planetary systems, you know, and stars. And so this is what we're seeing here. I can't get over how beautiful this is. Wow. So Messier 8 is a star-forming region. It's a stellar nursery. It's a place where stars are being born, and it's powered by a star right about here. It's an O-type star, hottest and brightest blue, and its temperature is so high that it causes massive stellar winds pushing outward, of course, which causes some of this billowing you see here. All right, it opens up something called a cavity in that area of space. But what's happening here also is that there's lots of hydrogen gas in here. Hydrogen is one of the primary components of the universe, and so when we see the hydrogen, we also see the capability for a hot star to ionize the hydrogen and force an electron off the hydrogen. And when that electron gets sent off the hydrogen, that's ionized, right? And when it comes back down in, okay, it gives off some of the energy it gained to leave the atom. And that energy it gives off is in the form of light, a reddish light like this. That is what we see. We see light that's very much like that. So this red color that you see here, this is characteristic of hydrogen alpha, as we call it, or that transition where we actually will see the hydrogen atom giving off that red light as the electron rejoins it. Very cool. But this now, see, this, what I'm getting at here is that we're watching and seeing this now live. This is just, and it's hard to believe that's a live shot. It almost looks like I'm showing you like a photograph, but I'm not. This is the live histogram coming in. That is to say, the distribution of the data on the image sensor. And just by grabbing some of these little dashed lines down here, I can move these and it will dynamically change the nature of the image. Look at that. How about that? Okay, now we're talking. Okay, this is just stunning. And since we're going to be here a couple minutes, I will maximize all of this to give us a little bit more real estate here. So.
That's a pleasing picture.
What's that?
I say that's a pleasing picture.
Isn't it nice?
Yeah, the deeper parts of the cloud, you get a little more red out of it, and that object up at the upper left, it's got that very red little section in it.
Yeah, right there. And there's a reflection nebula in there. Look at that. You know? This is the Lagoon Nebula and its surroundings. This is something that we've seen before in SkyTour LiveStream, but what we've seen didn't look this good. We only saw this. We never saw this. We never saw any of this. We never saw these star clouds in here in the same way. This is what happens. Okay, this is what happens, folks. We've kicked it up a notch. And that's good. I think it's a good thing. I don't think there's anybody out there that would disagree that this is a good kicking up of the notch here. Alright, so we'll let this come in a little bit. These are all photos that you can take, by the way. And these are large photos. If you look up here on the right side, here's the resolution. It's 4144 by 2822. Okay? That's the size in pixels. Alright? And the way that sensor fleshes out onto the sky is 2 degrees by 1.5 or so. And to show you that, I can do this. Okay, this is our sky view right here. It's not the actual view that we're looking at. This is actually just, if I move it, it moves. So it's just to show you the dimensions. Okay, so you can see the dimensions right here. Actually, you probably can't. It's not easily to read. So let me get out of that. There we go. So it's actually 2 degrees 9.92 minutes. Okay, by 1 degree 28 minutes. So it's basically 2 degrees by 1.5 degrees. So 2 degrees across by 1.5 degrees up. All right. So the moon's half a degree. Okay. So we're talking at least, 4 moons across, 4 full moons across, and 1.5, three moons tall. So just imagine a circular moon, circular moon, circular moon, and then 4 of them right across here. So that's roughly the size of the sky we're looking in. Pretty cool, huh? All right, and for where we're actually looking, this is where we're actually looking right now. So let's zoom in. You can see the Lagoon Nebula there, and we actually see this object over here. This right here is NGC 6559, and that's this cloud over here. All right, it's an H2 region.
Deeper red part there.
What's that?
There's a little deeper red part where you were pointing.
Yeah, right there.
Yeah, right there.
Hey Keith, thank you. Oh man, yeah. You know what? Keith donates. That's beautiful, Keith. Thank you. And I just got to make sure that you get props for this. The reason I'm here at all doing this is because of that guy right there, P&K Space Imaging. If Keith and Paul, who do the most fabulous moon and planet stream on the planet, if those guys did not, push me to do this, I would not be doing this. I never dreamed I'd be doing this. And I'll tell you right now, Keith, and this is a personal message for you. Before this, I was kind of lost. I didn't know what I wanted to do. I was an astronomer who wanted to do public outreach but didn't have an outlet. And then you came along and told me about streaming. I saw P&K, astonished by the quality of your guys' work. And I realized that, wow, these guys, man, they're reaching so many people. I saw this amazing number of people that you had as subscribers, and I was just blown away. I thought, geez, that's so many. How can that be? You know? And then I realized that, well, you know, I mean, maybe I can get some too. And sure enough, I followed your advice, and here we are. So, folks in the chat, you know, give P&K some love too, because they deserve it. The reason you're seeing these beautiful things is because of that guy right there. So, he actually is a very generous fella, you know. Oh, but he did steal a UFO from me. I just thought I'd mention that, you know. But that's a topic for another time, right, Keith? Actually, I'll tell you. You know, some of you know I have a company that I started back in the 90s called FX Models, letter F, letter X, for like special FX. And so it's a visual effects company, and we got our share of really cool projects to do for TVs, movies, and stuff like that, and as well as just regular collector work. Well, one of the collector projects I got was somebody drove from Los Angeles in a small S10 pickup from Los Angeles to Connecticut, and strapped in the back of their car, strapped in the back of that that pickup truck, was the original Jupiter 2 from Lost in Space. It was actually a copy of the fiberglass copy from the mold that made the original Jupiter 2. He brought it here and said, "I was told you might want this." He literally drove up unannounced. I didn't even know who the guy was, and I'm telling you, he drives up the driveway and says, "You want a Jupiter 2?" And I went, "What?" "This is a Jupiter 2 from the molds. Irwin Allen's estate, you know, got permission to mold this one, and I made it from the original molds. And I don't have anything I can do with it anymore. You want it?" I went, yeah. And I was stumbling over my words. So I put it here, and it was in my yard for 10 full years. I had planned to restore it, make it into the Jupiter 2 again. And it didn't quite work out. So along comes a spider by the name of Keith Ickes, who's P&K Space Imaging there. And I tell him, "Look what I got." And he goes, "Wow." And I saw it in his eyes. He was going to steal it. So rather than have him steal it, I gave it to him. And I think that's pretty cool. So he'll do something with it. But I told him if he ever sells it, he can probably get a pretty penny for it. But if he ever sells it, I told him, just give me, split it with me, split the cost, minus travel and gas and all that. But anyway, I thought it was kind of cool. Now, do you notice? Look at the detail. Oh my gosh, 26 frames stacked. I'm gonna zoom in a little. We can zoom in with this. That's the thing. It's a little awkward, and I don't know a quick way to do this. I'm gonna figure it out, but there has to be a key to do this, and not just doing it this way. But if I go to say 25%, that's a little better. Look at this up here. You can actually see these beautiful, almost three-dimensional illuminated clouds here. There's a lot of dust in here. There's a lot of gas in here. The red glow is the hydrogen gas. My God, I think this is the finest one we've ever done, Daryl.
Quite possibly.
Yeah. I'm gonna save this exactly as seen.
The depth on that is just amazing.
What's that?
The depth on that is just amazing.
Yeah, isn't it? I mean, look at how beautiful that is. Holy cow. We're gonna zoom in even more. There's gotta be a way to zoom in without, control and mouse wheel maybe? That'd be great. Whoa. Oh. Control mouse wheel. Yeah, that's what does it. That is so cool. How about control right mouse? What's that do? Control left mouse. I was hoping that would be for like for panning and stuff like that. Maybe shift. As you can see, I'm learning a little more. Look at this. There's like hardly any noise in here. That's stunning. Look at that. Wow. That's better than anything that we have done here for this particular nebula. Ever. Holy cow. Wow. I'm quite taken by this, to be honest with you. I just added the unsharp mask, and you can see that it's gotten a lot clearer right now. So that's what it's on. And this is with it off. The stars are a little duller, see? If I add an unsharp mask, it actually gets pretty sharp. Look at that. And it actually clarifies it. Look at this right here, Daryl. And everybody, look at this streak. See that little streak? See this dark object and it's streaking with streak stuff behind it? That looks like an area that is one of these high stellar wind areas. Gosh, this is just amazing. I have to drop the radius down a little bit to reduce the amount of unsharp masking, because it can really get out of control. It's very easy to overdo the unsharp mask. Holy cow. I'm just beside myself.
Pardon my ignorance. What exactly does unsharp masking do?
Okay. We wrote an image processing program that was used by the Hubble Space Telescope team for a while, and it was actually a matrix. Imagine a 3x3 matrix of numbers, right? 3 across, then the next row is 3 across, the next row is 3 across. And you basically put in there, -1, 0, or 1 in the different boxes. And what that does is that weights the value of what the system does on a per pixel basis. And the unsharp mask is a particular set of numbers in that matrix. It might be, it was so long ago when I wrote that. It might be like -1 at the 4 corners, 0 elsewhere with a 1 in the middle, maybe. I don't remember. But it's called a convolution matrix. And down here you'll see it says Wiener deconvolution. That actually sounds pretty bad, but that's another convolution matrix. Unsharp mask is the popular name for it. Okay, and here's Wiener deconvolution. It actually, I'm not as familiar with Wiener deconvolution as I am with the unsharp mask process.
Wiener convolution made me cringe a little bit.
Yeah, Wiener deconvolution sounds like something that, is like a special surgery to fix you from an accident or something. Yes, I'm afraid we're going to have to do a Wiener deconvolution on him, sir. Oh, no! Yes.
Let's move on.
Yeah, why'd you go down that path? It's all your fault. Nonsense, it was me. Look at this. Oh, I don't know what to say. I'm actually... I'm hypnotized by this. Look at that. Look at the detail in here. And to those folks like Isabella Melamed over in Sofia, Bulgaria, you are very interested in doing your own processing. Well, guess what? You're going to have a chance to do this processing as well. Look, here's another one of those little guys over here. See that? We had one over here, right there. A little, looks like a comet, but it's not. And we have one right there with 2 tails on it. So stellar winds shape nebulae and shape the formation of stars and or planets. Now keep in mind that if we were to go to this location and try to, for instance, make a guess as to how many planets there might be here, or whatever, the answer is probably quite a number, but not many not very many actually, that would have the capability to support life. And the reason is because this gas here is heated up to quite a temperature to do this ionization, which means that the stars responsible for exciting this gas to that kind of temperature are very hot. And probably, you know, we expect that because in a young cluster like this and with this nebula, we would expect that that would happen, and that does happen. Okay, look at that.
Did I hear your dog barking a second ago?
Yes.
Okay.
I have a harking dog, yes.
Will you excuse me for a moment, please?
Sure. As Keith says, you know, aliens aren't such a taboo subject anymore. That's right. That's right. And if you guys are of a mind to see it on August 15th, this is it this Sunday? Next Sunday, I think. On Travel Channel, actually Discovery Plus, there's a show coming on called Alien Invasion, and you know, I'm in it, so don't, you know, sorry about that, but there was 3 of us that were cast members for the show, and if it goes to series, well, then we got a lot more to do. But it's about the aliens and the potential for extraterrestrial life visiting us in the Hudson Valley of New York. So I think that's a pretty cool series. I just watched it a little while ago. I watched it. It's a 2-hour documentary, actually, but it was really actually quite well done. There's a chance for them to make things like this really stupid, and they didn't do it pretty stupid. This was actually done scientifically, and I was there to actually be kind of like the science guy of the team. Whatever. And it was neat, you know. I had a good time. I had things happen during the filming that I can't explain, and I still can't explain. And when I'm comfortable, I'll talk about it. But it was just something that I never expected. Wow, I'm stunned here. So, Tom, you guys enjoying this nebula right here, the lagoon? It's just beautiful. We've actually got. Oh wow, we've actually stacked 47 images. I think it's time to move on. But this is beautiful. I'll pause it right now, and then I will save it. Okay, I'm gonna save the stack. And for Isabella and others who want that, that's what this is for, to save the stack. And then for me to do additional processing after. And then I will save this exactly as it's seen on the screen. Quite a bit different though, huh? This is very different from what we used to be. We used to have that bluish cast. You can kind of see the faint thing there. That's gone, man. That's never going to happen again. You know? I turned down the music. And I'm turning me up. Is that better? Yeah, thanks, Keith and Tara and Isabella and It's very cool. Yeah. Yep. Oh my God. I mean, look at this. I can see depth. I feel like I'm not trying to say that we're doing this kind of quality of work, but it's almost like I feel like I'm looking at a Hubble image or something. It is just beauteous. Wow. And if we back way out, you'll see that we have a star cloud down here. Okay. And there is a globular cluster in that star cloud, or a cluster, I should say, in the star cloud. My gosh. Ay. I almost don't want to clear it, but I have to because we got to go on. I'm going to move on. I saved it already. Oh, gosh, that's beautiful. Yeah, beautiful, very beautiful. Let me quit that, and it goes back to what you'd see with a small telescope here in a second. Wow. Ay. Okay, so all that is there, but that's what you'd see in a small telescope. And you say, wow, look at that. But what you don't realize is that there's all this other stuff there. You know, like that. You know. It's just amazing. Okay, so we're going to come down here. We're going to go to the next object up for bids here on the prices, right? And it's just north of this. Right here. And this guy, where we're going to go now, is over here is where the scope is. And we're just going to go up a tiny bit. I know it's confusing with all the words there, but that's the names of all the things. We're coming up here from the Lagoon Nebula. We're coming up now to the Trifid Nebula. So I think we can just give ourselves a northern push right now. If you're looking at this screen here, you'll see the telescope right above me. You'll see the telescope moving up a little bit. But first thing I gotta do is take this back from 25 seconds to just the 1 second, because that's my acquisition speed. Isn't that beautiful? It's like looking at it with like the wrong glasses. Okay, and now we come down here and we're gonna go to this, the Trifid Nebula. So here we go. Up we go. And you'll see the screen change as we do. Okay. Normally I do this as a go-to. I'll just say Trifid go, but I'm not doing that tonight because of the fact that it went wonky on me. And I don't want to take the risk that you'll miss out on an evening with a telescope. Welcome back, Daryl.
Thank you.
All right.
Speaking of the Price is Right, did I ever tell you I went to the same high school as Bob Barker?
You did?
I did. Not at the same time, of course. But...
Wow. Adam Sandler knocked him out on a golf green.
Yeah.
Well.
My mom actually knew him many years ago.
Really?
Yeah. She worked for his wife's father.
Wow.
A grocery store.
That's cool.
He came back to visit my high school when I was a junior or senior.
Really?
Yeah. Good old Bob. I always liked him.
Really? You got to meet him?
No.
Oh.
I was shy.
Okay. Let's see if this is going to show us what I want to see. Yep, right in the middle. This is the Trifid Nebula, guys. This is another stellar nursery, and we'll do the same kind of thing we did for the Lagoon, but we'll do 25-second shots of this. All this in 25 seconds. I am just, wow, it's crazy. It's just beautiful. I can't get over it. I really can't. And let's live stack this too, by the way. And like I said, yeah, that's right. When it live stacks, it's really pushing the data. That's the previous guy. I gotta clear it. All right, and now we look at the histogram, which is the data. Here we are. Look at that. Wow. That's just, I mean, you can actually see the dark clouds in the Milky Way here. Okay, and they have these, you know, it's suspended in these wisps, you know. And in this area where there was a star formation, that actually illuminated, of course, caused the hydrogen gas in this region to glow, which is just incredible. So this is great. Did you see, Daryl? Were you there when I said I figured out how to zoom in without? You can use the as a key combination. I could use the zoom in. I don't have to go up there and tell it to zoom by a certain amount.
Yeah, I saw you do that.
I'm very happy that I found that out. Look at the subtle colors here, guys. See, as soon as you do a longer exposure and you start stacking, we have 3 frames stacked right now. Then you get that kind of process, you know? Okay, that's...
What passes me is the star patterns. I know it's just pareidolia, no doubt, but
maybe
to the upper right of the tripod there, there's like a little heart made out of flowers, and all the star chains and shapes, circles and stuff.
Yeah. Yeah, look at that. You see how many, there's additional stuff in here.
Yeah.
As I'm doing all this processing, I'm sorry. Let me just undo it all. Okay.
When you're doing processing on the fly like that, will that affect the final image, or is that just...
Nope, not at all. The final image is going to be a raw image. In the format, by the way, to those that want to play with these, the format is called FITS, right? It's an FTS or FITS. And the FITS files are going to require a little bit additional work on your part to get into. Oh, look at that. Wow. Look how much stuff is there, guys. Look how much stuff is there. It's almost like I've overexposed the nebula. You know? It's almost like I gotta do this. I gotta tone it down a little bit. Not that much. But look at that, huh? Wow. Well, look, that's the benefit of having a dark sky, right? I mean, this has sort of like been the dream of every astronomer, right? Is to have a nice dark sky.
Oh, yeah.
You can see the color rendition is beautiful. There's this beautiful red diffuse hydrogen glow throughout here. This is a reflection nebula up here. That's the section of the Trifid. That's like that guy right there. That's a reflection nebula. So this nebula is actually doing what the blue sky. Well, for the same reason the sky is blue. That's why this is blue. The high energy from this star is, or you know, the light that's from the star that's going off to these dust grains that are the dark dust grains that would normally be dark, like these dark areas you see elsewhere. They actually are absorbed by the dust, and the blue light is sent every which direction. It's scattered, and the rest of the light's allowed to pass through. That's called scattering, and it's selective scattering. It's only the blue end of the spectrum. The higher energy light gets easily scattered like that. And so when it's dust like this, we see these nebulae looking blue. And it's because only the blue component of the star's light is getting scattered. So the star doesn't have to be a totally bright blue star, but the blue light is getting scattered by it. Okay? And so this other thing down here, this guy, you know, this is actually the star forming region. That's actually just a dust cloud that has a star in it that's causing it to look like that. So that's pretty cool. All right, we've stacked 12 frames so far, and I'm still seeing some noise. Like if I zoom in, okay, and there's a few problems with the system still that I have to work out, but I can't do it from here. I might have to ask Tara to go out there again. I may have to do that. But
Ka-ching.
Huh? What'd you say? Ka-ching? What's that?
Oh, no, that's the sound a cash register makes.
Oh, okay.
Tara needs a raise. So does Marianne.
Oh, I get it now. I get it. So when we look in here, look at these extra dark lanes. These extra dark lanes are very hard to see from this location. But from there, they stand out, and they are like a sore thumb. Not only that, you see something else about the anatomy of this nebula. You notice that the blue part of the nebula, which is generally seen as smaller, is actually way bigger. It extends all the way out into here. See that? It's actually way bigger than this nebula. The star forming region, the blue scattering nebula, the reflection nebula, the blue one, is way further out, and that's pretty cool. Something I haven't been able to see from here. Here you basically see the blue light. It stops right around here, but here you can see it and the rest of the convolutions out there. Geez, that's beautiful.
Would it be fair to say that's all the same dust cloud? Perhaps the inner portion, the reddish portion, is where the ionization is going on, and then the blue part farther out is where it's not energetic enough to ionize anymore, but you're still seeing the reflection.
Yeah, that's a possibility. That's right. And the thing is that where it is ionizing, this red cloud here, that is actually hydrogen gas there for sure. There could be hydrogen out here, and this star may not be hot enough to show it, and that's a possibility. But it's also possible that this is actually just a region that's not. It's a region that's not, got any hydrogen in it, because hydrogen isn't evenly spread throughout the universe in any way. It's clumpy. The universe is clumpy,
Maybe the stellar wind from the hot star in the center has pushed the dust out. That's why we see the blue reflection farther out.
It could be. It could be. Isabella, yes, you mentioned FITS Liberator. That's a good program. That lets you view the FITS files, but you see them in black and white, okay? It doesn't show them to you like this. You won't see them in color. The individual files that this camera takes are black and white, but it is a one-shot color camera, and it will show you the color, of course. But this is the individual frames are going to be black and white, but you won't. You can recombine them in color when you get the stack. The stack will be in color, all right. But the individual raw frames are going to be black and white in the program. I don't know if that made sense. I almost didn't understand what I was saying. Look at this. Look, and here's something that is really we haven't seen in a while, if ever. There's a dark lane that crosses right here, and it's not quite dark enough. All right, but when I say that, it's not quite dark enough to not show the light coming through it from behind. But let's turn on that. Okay, we have the unsharp mask on now, and that looks pretty good. Let's see if we can increase it a little bit. See if that helps us. Wow, I've never seen the Trifid Nebula looking like this. This is really good, Daryl. Guys, it's pretty good.
I think the stars may have got bigger last time you shifted the unsharp mask, or whatever you did.
Well, I have the radius too big right now. I got to drop it so you have this little black halo around the stars. And now I dropped it down so it's gone. But that's the limitation, the limiting factor, with these convolution matrices, as they're called, that do this sharpening. You can't do too big a radius around the star. You can't make that matrix very big. You got to keep it small. Yeah. If you keep it small, then you won't have problems, and you won't get weird artifacts. Oh man. I'm sorry. The Trifid Nebula has always kind of been boring to me. But
boring. Beautiful.
I know, but it was always boring to me because it was always kind of like a red little thing with 3 leaves and a blue little thing that you could barely see. Here, it's a very different approach. And we stacked 26 of these guys. And this is how it's going to look to your eye. And we'll pause this now and move on after I save it. I have a particular order in which I save things. I save the 16-bit stack, which is the most important thing. Okay, and you'll see a notation in green at the top that was saved. And then I save the images exactly as seen as PNG files, PNG files. You don't process an image process the PNG file because it doesn't have all the data. The PNG file is small. The stack is huge comparatively, and that's because what we're doing is trying to take a lot of data, a lot of range of data, and put it into one package in a stack, right? So when you see this histogram down here, this is all the data on the picture, okay? Whatever this is up here, the brightest thing up here, it could be like the black of space, or it could be the white of the Milky Way, the white stars and red stars of the Milky Way. So if I move this over, this yellow line that you see, I'm intercepting more of the curve, see? So it's getting brighter and brighter and brighter, all right? And so what you do with these curves is you find the best logical location where the sky, where it's black, is black, but the clouds still show up, okay? And that's just past that point. I want it to be a little before that. Okay, so maybe just a little bit past that. I don't know. I can actually see some blue here.
You know what you should do, Mark?
What?
Post images over on Reddit.
Oh, you're right.
Get a lot of exposure that way, and
hey, that's
people will just ooh and ah the heck out of it, and I bet you'll draw a ton of followers too.
Wow, I should do that. I've never used Reddit. I gotta get up on that. Daryl's right.
I have seen a lot worse images there than what you're doing.
I think that's a compliment.
Well, of course it's a compliment. A lot of people don't know any better, but you know they ooh and ah over pictures that are way too punched up and stuff, and
yeah,
I think you just blow people's minds over there.
All right. Well, I gotta find out where that over there is.
LiveStream link or two, and go for it.
Tara sees a pineapple. I'm looking at some of the chat. Keith says it looks like a cracked Kinder Egg. What's a Kinder Egg?
German candy.
Ah. And does it have like a filling of like caramel or something in it, like strawberry or whatever?
The Kinder Egg, if I remember right, it's like a chocolate egg and it has a toy inside, sort of like a Happy Meal or something.
Yeah, yeah.
And they're not legal to sell here in the United States because some bureaucrat in Washington says it's a choking hazard for little kids.
Oh.
They're very popular in Europe, though.
Okay. I want to mention Ojo Aja says the size of the dust clouds may be as big as our Earth. Actually, if you can imagine this right here, just that one spot, that right across there is several light years in diameter. Our Earth isn't even at the most magnification we could ever do with any telescope we've ever made. We could never see our Earth at the distance of the Trifid Nebula like this. It would just be a tiniest dot. So,
when you saw the Bach globules earlier, those are probably as big or bigger than the entire solar system.
Yes, that's exactly correct. There's not a whole lot out there that's as big as the Earth, except maybe like a white dwarf. Neutron stars are the size of Manhattan Island, and they have like 1 billion tons in a teaspoon. They're so compressed. All right, well, this is just stunning. Again, I've never seen the Trifid Nebula this good. Wow. Yee. Okay, a bit of business right now I just have to do. I'm going to go and start up my all-sky cam out there. have an all-sky camera on the building so that I can check the status of the night sky, and I just do a quick 10-second photo and see if we have any problems out there. That's to say, clouds. There wasn't, ready for this? All day today, there wasn't a single cloud in the entire state of Arizona. There was some cumulus clouds, but not a whole lot. And as you can see, it's a beautiful night. And that looks like Saturn coming up over there in the east. This is east, this is south, this is north, that's west. And there's our Milky Way. I only did a 10-second shot. If I do like
Sorry, I was on mute.
Okay.
The brighter one is probably Jupiter.
Is Saturn? That's not Saturn?
It's probably Jupiter. Saturn's to its upper left.
This one?
Yes.
Oh, I think you're right. Yep. You're right. Jupiter has risen. Okay, cool. Thank you, thank you. Good. So we have clarity. We have a good night for doing this, I can tell you that. All right. So, that said, woohoo, let's have fun. Let's go. Oh, gosh, that's just beautiful. Wow. Let's get rid of the stack and get that full size back. Look at it one more time, full size. Wow. And of course, then it goes away because we have to move along, right? But it's beautiful. All right. So what I'll do now is go back to my 1-second exposures here, which don't look like much, I grant you. And then I'll drop this back down to a smaller size. Bring up this guy. And what do we want to go look at now? I think we should go up north to the Eagle. Well, actually, we should do the small Sagittarius star cloud first. Don't you think?
That's right there.
Yeah, it's right there. And then we'll go to the Eagle. Okay. All right. So, let's do that. We're going to go up to that. And the way we're going to do that, I'll just make sure that we have ourselves our highest rate of motion. Okay, there we do. Now it says rate equals max down below there. And up we go. You'll notice the telescope moving in the building there. You can see it. You can see how I've gone way past where I should. But that's okay. Now I'll come back down to it. Oh, wow. I can see that I'm doing too much, so I'm going to slow myself down here a little bit to a 1/4 degree per second. And now I will go north at a more stable rate. What is that? What is that guy? Oh, the red spider nebula is here. Well, let's see if we can see it. I don't doubt it. So we're pretty lined up. So the red spider nebula is probably going to be somewhere in here. Let me just do a quick shot of that, Daryl.
Sure.
See if I can see the red spider nebula. I've never seen the red spider nebula. Have you?
No.
Okay. Well, let's see if I can see it just regular, from the regular exposure here. No. Not in the 1-second shot, anyway. Just blew out someone's eyes who's watching on the big screen. Oh! Oh. Well, it must be buried in there somewhere. Okay. I guess. So what I'll do is go back to the 1 second and get us over to the Sagittarius star cloud, which I think is a little bit east of where I am.
Interesting. You're ideally suited for the small Sagittarius star cloud. I was reading up on it here.
Yeah.
So it says you need a 2-degree field to really see it.
Yeah.
See all. It's 600 light years across, and
yeah,
it's up to 10,000 light years deep.
Yeah, we can't tell how deep we're looking, unfortunately, right? I wish we could. Let's just.
And it's actually Messier 24.
The Sagittarius star cloud is, right?
Yeah, one of only 3 non-deep sky objects on Messier's list.
Wow.
I'd call it a dark sky object, but
yeah.
I guess it's not. It's not one object; it's a whole bunch of them.
Yeah. Okay. Well, now that we've done this, let's go here and do our quickie. Oh yeah, that's it, isn't it? There's that dark mass again up there. Another one right there. Okay, this is just a rapid fire test to try and look at it. I'm going to do 25 seconds again here. And thanks, guys, for coming out. I know that the times are a little weird because we're 3 hours off. Yes, I can do the northeast sky, Keith. You want to see something like up in Cassiopeia and Cepheus up there? What do you want to do? Oh, you want to see Andromeda. I almost went to Andromeda yesterday. I'm really anxious to see Andromeda from here. Yeah, it is definitely a twin on collision course with us, no doubt about it. Okay, there's the Sagittarius star cloud. Look at that.
Yeah, that's Barnard 92.
We're going to live stack this now. And it's got the Trifid as the last one in there. I cleared the stack. And now, wow. Holy cow.
The real dark cloud.
Yeah.
It is there are several Barnard objects in there. I had to look them up.
Yeah. Barnard objects, guys,
darkest
are
one is
dark nebulas.
I'm sorry.
I'm sorry. Barnard objects are from a catalog by Barnard, who was an astronomer, and they're actually these dark dust clouds. They're called Barnard objects. The Horsehead Nebula is a Barnard object.
But the real dark one there is Barnard 92, and the one to its upper left is Barnard 93.
All right. That's exactly what we're looking at.
And it's the same Barnard that Barnard star is named after. Also.
Same guy.
Yep.
Yeah, that's a little higher contrast, you can see. But we're going to just do... Let's see here. I don't want to do that. I want to zero all these out and just come back. This is not destructive to the image that's being generated. The image is still going to be really good at the end of all this. Let's try this guy. That's really bright. There's my dog doing his little trick again. Her trick.
Poor thing. Sounds like she's congested.
Well, she was shot. And, when she got shot by somebody, they ended up putting a bullet down by her liver. So that's what they think is causing this, in part.
Poor thing.
Yeah, well, she survived. She was we got her out from a drug bust. You know, they took the dog out of the car and they were going to euthanize her, and the dog licked the cop's face, and he said, "I can't kill this animal. This animal's beautiful." So
What kind
he
of
took.
dog?
Huh?
What kind of dog is she?
An Australian cattle dog with another mix in her.
Okay.
We named her Dingo because she looks sort of like an Australian dingo. And I like her. She's a cutie. Good little stupid thing. Yeah, okay.
Whoops. You're looking at the next galactic arm in when you look at small Sagittarius star cloud. It's over in the Sagittarius Carina arm of the galaxy.
Yep. Keith, dog has COVID.
10,000 light years deep.
How deep?
They said it's 600 light years across and up to 10,000 light years deep.
Okay. Well, we've actually been stacking only 9 frames here. We're going to keep going. Let me add a little bit of brightness to this so I can get some contrast out of these clouds. Wow. That's pretty cool. Wow.
10,000 to 16,000 light years.
Wow. Well, you know, there was a study done that showed that the Earth is actually not like 30,000 light years from the center. It's actually, I think, a little closer. Okay, you know what I want to know? I want to know what that line is right there. Is that a satellite that's going through that little cluster, or was that just an illusion?
Little line?
Right there.
Oh.
That's not a satellite. That's actually stars. Wow. By the way, guys, I just want to show you something up close. When we look really close here, you see the shape of the stars? That's due to a problem that with the lens system of the telescope. It's not what's called collimated. I have a collimation error, but that's something I can't fix unless I'm there in person, or I beg Tara to go out there and then I can talk her through it. But it's, yeah. Yeah, there's a ka-ching there. Yeah. Oh, a message for Bobby Burgess. Bobby Burgess, if you're still listening, we ordered more of your the books today so that you'll have your book that you ordered, or not ordered, but that you won. And I'll be giving you that. I'll be sending you that book. I'll sign it, of course, if you like. Tell me whose name you'd like me to sign it, and I will. Of course, that's our book, The Populated Universe, that I wrote about planets around other stars, the search for extraterrestrial life, and you know how it happened here. Okay, you notice something now? We've stacked 15 frames, but what do you notice now about the screen? Did you notice a change? Subtle. Did you notice the color change? There's been a subtle color change as now we're getting more color data, and that data is coming in and it's giving us more information.
I see a faint red on the left.
Yes,
and,
you do.
A little above center, maybe a little right,
Yep.
several yellowish looking stars.
Yep, we're getting more color. And it happens at a certain magical point, you know, when we're doing this. I'm going to see if I can... Let's see if I can get this to work. Because there's a 1 second delay with where you click and stuff, it's really kind of maddening. But this is... If I come way over, it's going to dump it down to almost... Yeah. So what you do is, This is effectively in Photoshop, like setting levels in Photoshop. This one, we can play with colors over here, all right, and it's pretty cool to, do that. We can mess with other values as well. RGB colors and so forth. I think that's pretty. 18 frames stacked so far.
I think that's gorgeous.
Yeah, I know. Yeah,
I'm just fascinated by that.
Yeah, I was gonna say you're partial to these guys.
Once upon a time, before Barnard, I guess, deduced their actual nature, they called those holes in space.
They did.
They thought there were no stars there, and it's just that's a cloud of dark dust, and you can't see through it.
That's right. They did.
There's like 3 stars you can see there, one pretty bright left of center in that dark cloud.
Yeah.
I assume they're foreground objects.
They may very well be. Yep. Just something else, man. I'll tell you, folks, tonight is going to be a banner night. It's a banner night. This is going to be one of the better nights we've had here. And I'm glad you're here. I'm glad you're here to witness it.
There's the Omega right above it.
That's right. We'll go to the Omega if you like.
Sure. We found this by accident the other night, didn't we?
Yeah.
We did?
Yeah, when we were trying to align the telescope, we were having trouble with it. And
right.
We found the Omega Nebula. It's like, okay. And so we were able to align on it. I did manage to do the alignment long distance, which is something that you normally have to do in person. I was able to do it by kind of faking out the telescope. And it really worked great. So far so good, and we're going to hope that it stays that way. Alright, I'm pausing this stack at 23 stacked frames. For those that want to try image processing, this will be available as well. I'm actually going to just be, from now on, I'll be giving you a link to the drive online where there's going to be a read-only collection of you. Actually, you get to see all the captures for all time, and you can just sift through them, take what you want, because that way it'll be great. Yes, Bobby, I said that I ordered, we ordered more books today, and your book is going to be on the way. I just have to sign it and send you your copy. All right? Good. All right, so let's clear this. We saved this guy. We're going to clear this and come back and go to 1 second, and then we're going to head up north a little bit to the Omega Nebula.
Thank you for indulging me.
What's that?
I said thank you for indulging me.
Oh no, that's fine. This is beautiful. Look at it. Why would we not? It's just stunning. Okay, and now we'll get rid of the stack for now. Okay. See, amazing, but in a 1 second time frame, you'd never see these. Actually, let's see if 1 second with the push process. Yeah, see, with the push process, you'll see it. The push process, the colors are not right, but what you're getting is you're getting details that are hidden in the darkness. Okay, so let's go back over to Stellarium here, and now from our location here, we're going to go up north, and we're going to go to the Omega Nebula. Let's see if I can leave the settings where they are and I have to change them. No, that'll work. Good. Looks like abstract art there on the left. Looks like abstract art. Okay. Oh, look at that. Look at that right there. That's kind of cool. I wonder what it is. Okay, so here comes the Omega Nebula now. The Omega Nebula is an interesting place, but it looks as if the star formation in the Omega Nebula may have come to an end at this point. It may very well be that the Omega is done with its star formation. But we'll see. There's more studies being done on it, of course. It was a star-forming region at one point. All right, so here's what we're gonna do. We're gonna undo what we just did there with the processing thing. And you can just barely see it at 1 second. And to see a nebula in 1 second like this is pretty good, considering that this nebula would not show in 1 second out here. But out there, it certainly does. Let's do our wonderful 25-second shots here. If you guys are having a good time, let me know, will you? Make sure you hit that like on the video too for me, so I can get some good likes from you on this. All right, moving right along to the Omega Nebula. We'll see it shortly. I think we'll see it shortly. Where to go? Huh?
I said we didn't lose our place, did we?
The telescope is sitting right there. Let's go see what happened.
I saw the Omega a second ago.
I know. Huh. I actually might have hit the button and sent it down by accident. Okay. That would be sensible. That would be a good explanation. So let's go back to this. All right, and now I think if I can believe... Oh, look. What the heck? It was just there. That's weird.
Yeah.
All right, let me just get us back in there. The telescope hadn't moved. That's the thing. I don't know why it did what it did. Let me go back to doing this right here. Okay, there it is. All right. That's actually kind of a nice shot because there's stuff over here. But there's more out here too, so maybe just a little bit eastward. Yeah, we'll go with that. Okay. All right, now let's go back to the live stack and let's actually set this to 25 seconds. And clear. That was the galaxy shot there. Oh, I forgot to clear it. That's why it was showing wrong. That was the Sagittarius star cloud shot. I forgot to clear the live stack. Yeah, we'll get it now. Hey, Andy Morrow, how you doing? Okay, sorry, let me just pop this out of here. Okay. Oh, yeah, look at you. Wow. There we go. That's a nice shot, huh? Look at this beautiful red. just zoom in here to look at what we're doing here. 2 frames stacked.
There's that duck decoy I always see.
Yeah, right. Hey, Leslie Trailer, how are you? Welcome. Good to see you. Yep. Don't worry, Keith. I'll try and get to the Andromeda Galaxy, baby, if we can. It's going to fit the whole thing in, almost the whole thing in the view. There might be a little bit sticking out. Let me just maximize the size of this whole thing for now, because we know we know what we're doing now. Let's just kind of bring this over. Wow. Interesting how this section of the nebula is a lighter orangey looking versus this red diffuse nebula here. That has to do with the intensity of the nebula and how it sort of causes the sensor to saturate a little bit into it, you know. Oh, thanks, Leslie. I'm glad you're having a good time. I think you can tell I am too. Yeah. This is the Omega Nebula, as we talked about, Messier 17, the 17th object for that's in the catalog created by Charles Messier of objects not to be confused with comets. He was a comet hunter. You know.
Imagine how different things looked to him.
I know, huh?
He just had a little bitty telescope. It really wasn't a very good one.
Yeah.
He saw much less than we see nowadays.
Yeah. Oh, you saw me on a show on Science Channel? Which one was it, Leslie? Don't forget August 15th. The 2-hour documentary on Travel Channel's Discovery Plus is going to be on. That we did. It's called Alien Invasion. And 3 of us went around Hudson Valley, New York, and we were investigating what was going on out there. And we made some inroads into figuring out what extraterrestrial beings might want to do with us here. You know, we figured out that we can't use our standard technology to really detect whether they're here or not. It would need to be a different technology. And so we used some of that different technology, actually. And we actually got some really interesting responses. I actually said it on the air. I said it in the show, and they put it in. I said, I'm a science guy, and this stuff doesn't happen to me. You know, so it was really kind of cool. You know. Crystals and Cats, how you doing? Hello, welcome. So I want to know where's everybody from? It's a different time zone type thing. I mean, normally we started at like 8 p.m. You know, here, our time in the East Coast, but you know, now because the observatory we're running is in the western desert of Arizona, I have to say that we're probably trying to, you know, fit in time to stream, but we have to start more near midnight when it's dark in Arizona, you know. And Tara D, who's here, is one of the very important people to SkyTour LiveStream West, as is Marianne Robb. The 2 of them have been boots on the ground when I couldn't be there, and then when I'm there, they're there with me. making sure that everything goes right and according to plan in there. I just think that she's, you know, those two are very amazing people. You know. Yeah, the Waterfowl Nebula. There you go, Tara. Yeah. Yeah, if we rotate it over, it looks like a duck decoy. I get you. You know.
Yeah, as I mentioned to her, some people call it the Swan Nebula.
Yes, that's right. The swan. That's right.
Yeah.
Because it also looks like a swan.
Yeah, and classically trained astronomers, they call it the Omega Nebula because they think it looks like the Greek letter Omega.
Well, the capital letter Omega, yes.
Yeah.
It looks like a capital Omega. It doesn't look like a small Omega. Well, okay. I guess it could be, but in the capital Omega is like this. It comes over and like that, and it goes over like that. The regular small Omega, the small letter, is like a W. And that could kind of look like that. Depends on your telescope.
Some call it the Checkmark Nebula, too.
And that's something I don't understand. But, okay. Okay, we've done 17 frames so far. Let's zoom in and see what we got. Like I said, we still have a collimation issue, but... Oh, yeah, let's get us in there right there. That's actually pretty cool looking. Look at that, we come in this far, and really only then do we actually start to see this pixelation. Not bad. Very, very complex in there. Yep. And this is Dark Nebula in here, and all throughout here. So that's what we're seeing there.
I wonder if the red star in the Dark Nebula is red, or is it due to extinction that it looks red?
Or it's just a foreground object, maybe. But yeah, that'd be interesting to find out.
Sure is pretty.
Yeah, it is. So PG's in Pennsylvania, Crystals and Cats in NYC, Tara and Marie is in Seattle. Fantastic. And Anahata 77 is in Pagosa Springs, Colorado. That's really cool. Yeah, it's Discovery Plus, Leslie, is what that's on. I thought it came out pretty good. You know, I watched it. I have a lot of trouble seeing me on the screen. Really, I do. I was watching it kind of like this, you know, because that's like it's, you know, it's you, and it's like, oh, the slightest little twitch that you do, you think, oh, everybody saw that, and they think I'm an idiot, you know. But you know, it's okay. I think I've done enough of it to worry less than I used to. I used to be very self-conscious. Now I say I don't care anymore. I just don't care anymore. Wow, this is really something. Again, you know, it's a really nice night out there, and I honestly haven't seen the Omega look this good. Let me see if I can do another processing thing. Yeah, look at that. How's that for some additional data, you know, detail for the nebula, huh? Look at this, Daryl. It doesn't even look like the Omega Nebula anymore. See that?
I do.
I'm sorry. It's kind of being facetious in a way, you know. Wow. Look at that. So if we back out here. Oops. Okay, now we do it. Now that's what kind of data, that's what kind of region this nebula's in. Look at that. Wow. I'll tell you right now, guys, honestly, I've never seen this before. I've never seen this before. This is new to me right here. It's you know, mind-bogglingly beautiful. Mind-bogglingly beautiful.
We were looking at it at F8 or F10, whatever.
Yeah.
You were just zoomed in on the
center part.
Yep, that, and we never saw any of the stuff around it. That's what's great about low-power wide-field astronomy. I mean, you're looking right into the Milky Way right here, folks.
Yeah, that's right.
That's millions of stars.
Yep. Outstanding. I'm going to save exactly a scene again, because I don't know if I got it. Maybe I did. Okay. Wow. All right, well, this is 27 frames. I think I'll call it here on the Omega Nebula. And pause it right here.
You know what's next, don't you?
What?
You know what's next, don't you?
Yeah, it's right above it.
Uh-huh.
I think it's going to be absolutely stunning.
Oh, yeah.
So we're going to clear this, and Daryl's teasing you guys because, he's not telling you what's next, but I know what's next. It's a giant bird. Okay? It's a giant bird. And, oh, look at you. I have to quit this. All right, clear it first. And it's actually the national symbol for the United States. National bird. That's the nebula we're going to right now. Know what it is? I know you do, Daryl.
Sure. Messier 16.
Yes.
Ben Franklin wanted the turkey to be the national bird.
What?
You never heard that?
Say that again?
Ben Franklin wanted the turkey to be the national bird.
Well, I mean, it stood to reason because people were eating it all over the place.
Well, the wild turkey was a whole different critter,
Yeah.
Wild turkeys are very canny animals.
Uncanny or canny?
Canny. Smart.
Huh. All right. Okay, and now...
This isn't a turkey.
No, it's not. It's the Eagle Nebula. Yeah, and the Eagle Nebula is also known as the home of the Pillars of Creation, if you recall.
Oh, yeah.
And we should see it. Here it is. I'll swipe it over for you so you can see it. But it's in the view here. There it is. Doesn't look like much, does it?
Not yet.
Not yet. But it does when we actually start to add a little bit of processing. There. See, this is more approximately what we would take here when we would look at it. This is kind of what we would see. And we say, ooh, wow, the eagle. And we didn't know any better. I didn't. Well, now I do. When we actually do this again, we're going to use the same dedicated, we're going to get another one, same dedicated astronomy camera here for this telescope when it goes into the new building here. So we're going to have two telescopes, and we'll probably start in Connecticut and then stream Arizona at the end of the night as we're moving forward through the night. That's all cool. Okay, so...
You ever considered pulling strings at KGRA and maybe doing a SkyTour radio, SkyTour LiveStream?
Yes, actually, believe it or not, they actually like that idea and they want to do it. Yeah, I just haven't I haven't had the time to actually implement that with them, but they want to do that. I will be teaching classes too with KGRA in astronomy class. So this will be cool. 25 seconds. Okay. Yeah. You tell me. Look at this. Look at the eagle. Now, when you look at this now, this looks like the head of the eagle. These look like the outstretched wings. And these, the pillars of creation, actually look like they could be the talons of the eagle facing you. Doesn't it? When we see it like this?
I know what you're saying, yes.
Yeah.
I mean, I don't really even see the pillars of creation in that image.
Oh, they're right here.
I mean, that's... Maybe the eagle would be one that would benefit from more magnification.
Yeah. Well, I'll show you.
Okay, there you go.
Okay.
There's what I see as the eagle, that kind of V shape.
Yeah.
Wing on the left, the head's pointing toward the upper right, and its foot down below it.
Yeah. I'll take this moment, though, to point out for you guys. You notice when I zoom in, you see how you got all this mottled noise in here, that multicolored noise? That's going to vanish. You're going to see that go away as we start stacking more frames. All right? And that's what's the beautiful part about this camera. It allows me to do all of that internally. So we're capturing this vast panoply of stars. It's just so beautiful. I honestly don't know what to say. I do know, though, that I probably still have the unsharp mask on. I'm going to cut that down for this. I'll bring it up as needed. Is that not beautiful? My gosh. This camera, by the way, is like one of the highest rated cameras of all types of cameras for doing astronomy. It's this camera is one of the top ones. And that doesn't mean it's the most expensive. It just means that it's really one of the top rated. The camera we were using before cost me $2,500 here, and this one was literally $1,000 of our GoFundMe money, and it was smaller, easier to use, has a cooler on board to actually cool the temperature down here. I mentioned this earlier to those of you that were here. The target temperature is minus 10 degrees Celsius, and it's running at minus 7.8 right now. That's about as low as it can go, while the temperature inside is as high as it is. The temperature inside the building is still close to 90. It's really a hot house out there, in the desert. I'll show you the temperature exactly, because I have a focusing system that's temperature dependent. We can connect, and here's our focusing value that we use. And the temperature in the building right now is 32 Celsius. Okay, that's 90.7. All right, so 32.6. All right, so it's still over 90 inside the building. It's 90 at the focuser, and the focuser detects the temperature, and based on the temperature, it can alter the focus, because as the temperature changes, then the focus changes on the scope, which is really interesting. And since I have it focused, I do not need to have the focuser up, so I can bring it up as needed, but I don't need it now. All right, we've done 10 frames at 25 seconds of the eagle. Let's go back and kind of zoom in and see what else we got. See what it looks like.
I can kind of see what you were saying, Mark.
What about the eagle?
Yeah,
right there,
wings spread to the upper left and lower right, and the head there toward the top.
Yeah, talons.
Maybe the brightest part of the nebula is like its breast or its belly.
Yeah, exactly. It's a bald eagle seen through red glasses. And this right here is his beak, pointing right at you. See it? I remember coming across a dead bald eagle in the highway up here. And I called, I forget who I called. I called the Connecticut State Game people or whatever. Yeah. And, you know, they had the nerve to say to me, well, you know, if you take a feather, that's a $1,000 fine. And I went, hey, listen. And I used a colorful epithet. I said, hey, listen, Mr. Beep. Okay, I'm calling you to tell you there's a dead eagle in your highway. Okay? And you're sitting there reading me a riot act? Screw you, pal. And I hung up. I went on my way. You know?
There is a really cool site on YouTube. It's, oh gosh, it's some Wildlife Federation thing out in Utah. I forget its name.
Yeah.
I'm subscribed to it, actually. It's this old guy. He's a master falconer, and he's a bird rescuer and rehabilitator. He does some really cool videos where he goes out and rescues and rehabilitates eagles and owls and all this stuff. And I just happened to watch one of his episodes just yesterday where he was going to the going wherever, like you said, Utah Game and Fish Commission or whatever, and he had a great big trash bag full of dead eagles he wasn't able to save, and he has to surrender them because the feds take the bodies and recover the feathers and give them to Native Americans for them to use in their ceremonies.
That's right. That's right.
And that's why it's illegal to take an eagle feather.
That's right. And the odd thing is, my mother was Native American. So if I wanted to, I could probably argue that I could take that eagle feather, but it's just not worth it. I just felt bad that this eagle was dead in the road. And that was my primary thing, you know.
It's Southwest Wildlife Foundation of Utah.
Okay.
Give me a second, I'll put up a link in chat.
All right.
Really great videos. Big birds, little birds, mostly raptors.
Yeah. 6119, what do you mean you're not sure they're stars? What'd I miss?
That's the guy's YouTube page, folks. You might check that out sometime. Not right now, but save it for later. It's cool page.
Okay, thanks.
Sure.
And if you're visiting and you haven't subscribed to SkyTour LiveStream, this is what you get. And you also get the data. You know, you're not just a visual participant. You can be an active participant. If you know your sky, if you have some ideas, if you know about a nebula or you know about something cool in the sky, let us know. If it's up, we'll go for it. We'll check it out. We've hunted down comets. We actually watched comets moving across the sky. All right? And it was really beautiful to actually capture them moving across the sky. Asteroids, we tracked an asteroid across the sky one night. It was really neat. So there's a lot that we can do here. And now that we're in this new system out there, oh gosh, it's just amazing. We're going to keep going north, by the way, into the Cygnus Milky Way. And I am, it's about 2 a.m. here for me. And I've got the energy of a freaking, little kid. I have no intention of going to sleep right now. Happened.
Take a deep breath.
Yeah.
Take 2 or 3.
I know. So you can get a word in edgewise. I know I go crazy.
Lay off the caffeine.
What's that?
I said lay off the caffeine.
Yeah. I'm not drinking caffeine. I'm drinking water. In this invisible bottle, apparently.
I don't know if I'll be able to keep up with you or not. I'll try to stick it out a while longer.
Okay, no, I understand. But, you're going to miss the veil if you do. Alright, let's see. We got 23 stacked here. Let's go see. It's really interesting to actually have. Oh, look how beautiful that looks in there. Let me actually go into the enhancement. Let me turn on the unsharp mask right now and see what it does for that. Oh, look at that. It really gives some enhancement there. You can see the detail in there. Look at that. That's really pretty. Look at the extra detail in here. Wow. Remember that noise I told you about? Notice it's gone? The stack removes the noise. When you stack like that, it averages out that noise. So that's the secret to getting really good shots. Okay, we're going to pause this now, and we'll stop at 25. And I will first... Oh my gosh, that's beautiful. I'm going to save this just as seen. Exactly as seen. Let me make sure it's what we want. Back out all the way. Wow. Absolutely unbelievable. Okay, so we'll save it exactly as seen, and then we'll save the stack. That save exactly as seen acts as sort of like a thumbnail for me. Let me just do a 16-bit stack. Oh, did it do it already? Oh, look at that. I guess it does. Okay. Yeah, hang on, Keith. If Andromeda's up there, I'll find it. Okay, I know it's coming up, but I have to be careful about whether it's actually visible. It has to get up to a certain altitude before it's visible, right? So, okay, in the Eagle Nebula, I have taken care of saving everything, so now I can send it away. All right, and stop the stack. In my process, go down to 1 second again. Oh my. I just... It's beautiful. It's beautiful. Ah! Okay, so... Eagle right there. And let's get out of this. All right. Yeah, where else are we gonna go now? What's this guy? I forget. Probably. Okay, I don't need him. Okay. All right, let's go up. Should we just try, let's go up to the wild duck and check out the wild duck and the Scutum star cloud.
I knew you were going to say that.
You did?
Yeah.
Okay.
I mean, it's
on the way.
Going up the Milky Way, I guess.
It's just an exit off the Milky Way. You know? Okay, so here we go. You can see the telescope moving in the dome. Sorry, not dome. I don't have a dome anymore. The building. And then we'll move over. Okay. Now we just go up a little more. And I change the rate of motion to a slower rate. as you can see down here, 1/4 degree per second, and now we can close in on our quarry. Let's go duck hunting. Right. Okay.
Ducks are cool.
Yeah.
Geese are obnoxious as heck.
Yeah. We have a problem with geese at our lake here. We have a house that sits up over a lake, and it's actually a very nice location, you know, but the geese come in, and now they've added geese away, which is these amber lights that geese absolutely hate. And so the geese don't stay. Not anymore. They did, but not anymore. Alright, so let's just go and come over a little more here. Bring the wild duck in. Center up. Okay. And we should have the wild duck now right about here. Maybe, let's find out if our alignment is good. So we come back over here. Well, actually, I don't know why I keep forgetting to do this. I just can do this and let's see. Yeah, there it is. Beauteous. Beautiful. Oh yeah. Oh yeah. Okay, so now let's go in and let's do a live stack. But first we're going to set up the live stack. It'll be 25 seconds. And you might say, well, it's just a cluster. How exciting is that? Well, you'll see. It's actually quite exciting. All right. Once we get the first one in, you'll see how this is going to play out. This region is actually very, very dense. Damn you, Starlink! May not be Starlink. Check it out. That is beautiful. Let me get rid of all the processing. There we go. Get rid of all the processing, and then put the processing back for this, and maybe this guy. You can see those dark lanes in there. That's beautiful. But we'll wait. We shall wait a little bit longer. Oh, look at that. See what I mean by density? This is a very dense location. Tremendous amount of stuff here. Now this cluster is called Messier 11. It's also known as the Wild Duck Cluster. But it's not a globular cluster. And you'll say, what? Of course it's a globular cluster. Look at it. No, it's not, actually. It's a very tight open cluster. That is where stars formed in a nebula at one point. And these are young hot stars. And probably only a few millions of years old. And when they formed, they had these very, very powerful stellar winds, and they pushed all that gas away. And if there was a nebula here at one time, it's no longer here. It's been dispersed. Spilled glitter. Well spoken, Tara. Spoken from the artist. Tara's our creative director, by the way, for SkyTour LiveStream West. Yes, sir. Okay, let me... we'll just let this stack up a bit because it's just so much fun. Wow.
$1,326.
I love it. Daryl, you don't have any idea what they don't see. They don't see this.
Oh.
No worries. I'm about to show them. Let's go back over here. All right. Beautiful satellite. So this is, so you can see how rich the clusters are. Now, what Daryl was talking about, by the way, is I've I brought in an image because I mentioned how Tara is our creative director, and the reason is because of this. This is the door she made for our observatory. That's a stylistic rendering of the Orion Nebula, and this is SkyTour LiveStream. And when we look at this, we're actually seeing we're seeing bottle caps. These are bottle caps on the door. And you know, when you look at this in reality, these are all bottle caps that she took the time to put in here on the door. You can see every single bottle cap, which leads to our contest that has yet to be claimed, which is if you can come within a 25 count of the actual number of bottle caps on this door. And this photo has been up on my website. I'm sorry, up on the SkyTour LiveStream site. You can get to this photo. If you can get to within 25 of the bottle caps, you win one of our 3D printed Earth's moons, which is a spherical, beautiful moon with almost every crater visible because we make it right here on our SLA printer in my workshop. And we'll be happy to send you one. And it's all hand painted. It's actually a several $100 piece of art. But if you can get this count, which you can see every bottle cap, by the way, in these images you can see every bottle cap. You just have to work out a system to count them all. If you can do it, then it's yours. You can have that. You can have that. So anyway, that's just for now.
I see Guinness. I see.
Yes, you did.
Dose Key. I was going to compliment Tara on her taste in beer, but I see Bud Light in there too.
Well, that's not her fault. She actually collected those bottle caps. Most of those things she never drank.
Okay.
Yeah. I don't even know if she's still. I don't know if she's actually still listening right now. But it is, 11 o'clock for her in Arizona. Gosh, look at this. It's beautiful. We've done a stack of 14. Oh, yeah, she's here.
Interesting. The one big dust cloud in that image going out of the top of the field of view now, but it's like a long, skinny, sinuous thing.
Yeah, you're talking about this.
No, to the left of that.
Oh, you mean this guy?
No, to the right of that. Up the top of the image,
Yeah.
a little bit right of center.
Oh, like this?
That right there.
This right here.
To the left. To the left.
That?
That right there. Yes.
Okay. That's the first thing I pointed at, wasn't it?
I don't know. I thought you pointed farther right.
Oh, okay. Maybe I did. Wow, 16 stacked images. See, the live stacking approach, guys, is really the only way to fly. It really is the only way to fly. Because now you get to see everything that's going on. I don't hide anything. You get to see everything, all the evils, all the good stuff. You get to see it all. And Tara officially answered you, said, way off, Daryl, as far as the count.
Yeah, I know.
Okay.
2,652.
Look at that right there. Wow, that's beautiful. Wow. That is just stunning. So, Measure 11 is near, in the sky anyway, is near the Scutum star cloud, which is what this is here. And it's sitting right on the left border. I was going to say western. Leftern border.
Seeing that almost makes me think that the wild duck cluster is like in the foreground to the star cloud.
Oh yeah, it most certainly is. But we'd have to actually, let's go see. We can do that right now. It might be approximate, but we can figure it out. So the wild duck cluster, its distance is about 6,000 light years. And that star cloud, that's got to be, what, 12,000 light years away at least, maybe? I'm not sure.
Just there to the lower right of the duck cluster, and still right there where your pointer is.
Yeah.
Click on that.
And it's hard to give a distance to it because, you know, it's a large three-dimensional object.
Yeah.
So they don't. Yeah. Parallactic angle, well. Yeah, it's hard to get a distance to those things. This red square is just a field of view, guys, and it's not tied to the scope location. I mean, why make it tied to that? Because that'd be logical, right?
Let me see if I can find anything.
It's alright. Okay, 22 stacked images. We're going to pause this now. Okay, and now we're going to say save. 16-bit stack. And then we're going to save as seen. Okay. And now we have saved that beautiful object. Change the time for the exposure back to 1 second. And we'll actually give some modification here. Okay, now let's go back to Stellarium and go to the next object up for bids on The Price is Right. So how are we going to do that? Well, we're going to go pretty far this time, I think. Let me just back out a bit. Okay. Yeah, I really want to go way up there. I did last night, and it was beautiful. Alright, let's just do this. Let's take a look. Yeah, that's... Yeah. Not yet.
Where are you headed now?
I'm starting to make my way up this way, toward the north, and continue cruising up the Milky Way, which I think is probably a good idea. Don't you think? I do.
Sure.
Right, so now we'll head up north a little more. Okay. And I gotta get rid of this. Oops, that's the wrong one. And get back on my right ascension lines. And I want to... Oh, wait a minute. I forgot to get rid of this. Let me clear this. And get out of this. Okay. Now we're in just sky. Yay. Okay. Okay, back here. Now we're gonna come up and go east a bit. East a bit more. You might be able to guess, those of you that know something about the sky, you might be able to guess where we're going now. Heading up north in the Milky Way. Yep, a little more east. Like I said, normally I let the telescope do all the finding, but tonight, because we had issues with the telescope yesterday, I don't want to do that. Oh, what's that over there? I wonder. It's really small. Okay, we're gonna... Yes, don't tell me you can't reconnect. Just a second. I had one camera go and give me a little bit of an issue right there. Let's just take care of getting that back. There we go. Okay, and now let's go and set my speed to our favorite number of degrees per second, which is 0.25. And now we can head over a little bit to the east with this. Yep. Obviously you see it there. Oh, you know where we are.
Oh, yeah.
Oh, yeah. This is the Dumbbell Nebula. It's a planetary nebula. What's that? Well, in a telescope, it appears to look like a planet. That's why they call it a planetary nebula. Some of them are round. Dumbbell Nebula is not one of those. It's what's called a bipolar nebula. That doesn't mean it has behavioral issues. It means that it's actually a nebula that has material that's spewed out in a different direction, one on each side, and it kind of made these poles like this. Think of an ice skater spinning as they close their arms in and they spin faster. Well, if the skater is a female, you notice the dress goes flailing right out to the sides. In the same way, this was a rapid rotating star at one point, and when it went into the final stages of its life, it would bloat. Okay, and as it would bloat, it would tend to slough off some of the outer layers on it, and that sloughing off process is something that clearly causes the material to come off at a certain way on the nebula. Okay, when the nebula is created, it comes off a certain way, and that's not uncommon. I'm going to remove the instant processing here for a second and see what we get when we do the 25-second shot. It's probably going to be blown out and be pretty bright. Yeah.
When I looked at the dumbbell, with the eye through the telescope,
yeah,
it always looked round to me, and it looked almost like the ghost of a planet. The two lobes you see there.
Yep. They do tend to make it look that way. You're right.
We're almost like seeing North and South America
mm-hmm.
on a globe. You could really get a feel for why they call them planetary nebulas.
Yep. So there you go. That's the dumbbell right there. And let's see if we can get it a little closer. There's a central star in the middle that it's just barely visible. But this is a couple light years across, this nebula. Hey, look who's here. Tana. Good to see ya. We'll stack a few of these. This has been a banner evening, I'll tell you. It's been just incredible. Yep, there's a central star right there.
Uh-huh.
By doing unsharp masking on the image, I could see it.
That's a little white dwarf, too.
That's right. And that little...
Tiny little thing.
What? It's the size of the Earth.
Yeah. And we can still see it.
Yep. Yep. There's an upper limit to the size of these, and the reason is more than it's just not that it goes to a certain size and then stops. It keeps going. But what happens is it's actually going in a way that takes it outside of the realm of the ability of the star to ionize the gas. Because you're looking at this greenish blue color. That greenish blue color is due to oxygen. And when the star sloughs off its outer layers, it puffs them out. They get puffed off, and the star was formerly a red supergiant at that point. That's where it evolved to from whatever type it was. It was a star that was more or less about the mass of the sun or so, maybe a little more, a little less. And when it grew to a supergiant size, it got so big that those outer layers are only tenuously held to the star by gravity. So the slightest perturbation, the slightest additional pulse of energy can push those off, and they're free. And they just keep going. And out they go, never to come back. And that's what happened here. So many planetary nebulas have shells, concentric shells, that they've done, that they have ended up sloughing off like that. And they have different chemistry in there because of the fact that this is material that was in the outer envelope of the star, stuff that the star was already made with. So there's lots of oxygen atoms, there's hydrogen atoms, of course. And we see in the ionization here, we see this O3, doubly ionized oxygen here. And the red is hydrogen and neon that is also made in the star's atmosphere as well. I mean, not the hydrogen, but the neon. But that, it could be that if it won't make neon unless it's a little more massive. So it's pretty cool looking at this. Our star will probably never make beyond some carbon and nitrogen and some oxygen. That's about it. All right, Bobby, thanks for coming. All right, so we did 11 frames here, and I'm going to shut off the unsharp mask. And then we'll go back to our histogram. Let's get rid of this guy. Yeah, see, too much. Let's do this. That's actually more like what it really looks like too. A little bluish green. But there it is, the Dumbbell Nebula. Alright. Oops, that's a little small, I'm sorry. It's this silly delay on this. It's not because it's so far away, it's delayed because of the fact that the internet out there is extremely slow. Sadly. Okay, save as 16-bit stack, save 14 images. And then save exactly as seen. There we go. Okay, and now we're going to pause this stack and we're going to clear it. Alright, and we'll move on to the next thing. Set the time to 1 second exposures. You still there, Daryl?
Barely.
Yeah, okay. If you need to run, go ahead. It's okay.
Yeah, this might be a good time. Yeah, I am about to fall asleep where I sit.
Okay.
And, I think I'm going to call it a night. Great show, Mark. And,
yeah, this is wonderful, huh? This working great.
The telescope, and thanks to everybody for coming, and hope you stick around and watch the rest of the show. I just, it's past my bedtime.
All right, Daryl.
Y'all take care. Have a good night.
Hey, thanks for coming out, man.
Bye-bye.
Bye-bye. Well, I guess it's just you and me, huh, punk? Do you feel lucky? Well, do ya, punk? I do. All right. Now, here's where we're going. This might be our final object for tonight, but it really is the object you don't want to miss. This is one you don't want to miss. Okay. And we'll go from, say, here. Okay. So now we are going to head up a little more. Okay. We're going to go north a little more. Okay. If you look in the dome, you can see the telescope is almost pointing straight up. Okay. Then we go east. Go east, young man. But I'm supposed to go west. No, go east. Okay, we're going to go east now. Okay, and now I'm going to activate the stretch, and you'll be able to watch what comes in here. It's actually really cool. Okay, we just visited a planetary nebula. It's one way that stars die, but we're going to go to a different nebula now that shows us the way stars die when they're much more massive than the sun. And some of you know this already. These are stars that will die by going into a supernova. All right, they will explode and they will spew their contents to the interstellar medium. And so we're going to go and look at that remnant right now. I'm getting there. Our goal is this spot right here. We're almost there. Okay. I gotta go north a little bit. There we go. We're right in the middle of it right now. And you can see some of it on the left. You can see some of it on the right. It is by far one of the most beautiful locations in the sky. So let's go east a little bit and bring in the eastern veil. This is, think of this as a giant explosion in space that actually caused a spherical debris shell to expand away from the point where the star had exploded. And that explosion was by far one of the most massive explosions in the universe that the universe has to offer, the supernova. All right, so let's go back here now. And let's set this to, this is a 1 second shot. Here, it takes 30 seconds minimally to capture something just a little bit fainter than that. 1 second, okay, does that here, okay. 25 seconds. All right, and we have all of our settings right. As the temperature drops in the building, I can actually get the, you can see the coolers drop down to -8 now from -7. All right, it's struggling, but we're getting there. Okay, we're gonna live stack this as well, and you'll want me to, trust me. Okay, we're gonna clear this, and it's all clear. All clear. And that's too much, so we're gonna pull that down. And now we're gonna do a little bit here. A little bit here. There we go. Wow. Yowza. Now that's a beautiful nebula. I'm gonna back out a little bit so we can see it. This is the Veil Nebula. It's like I said, a supernova remnant. You can see this is one half of it here, one part of it, and it's curved because somewhere in the center is where the star was that blew up. This was stuff in the middle. It goes up and over. Then there's a piece on the right which is very, very sharply defined. I don't know if you remember me saying earlier, but when a star goes into that stage where it's a very, very hot star and it's going to explode, it means it's very massive and it's giving off a lot of ultraviolet radiation. When it does that, the star is also going to basically clear a spherical area all around itself, way far out. That's called a cavity. It makes a cavity in the interstellar medium that wipes out all the dust, pushes it all away with its stellar winds. That's what happened here. But when the explosion occurred, that material moved out so fast that it eventually overtook the cavity that was slowly expanding as the star was still, fusing normally. And after that material reached that, it hit the interstellar medium after and slowed down really fast and made what are called shock fronts. And you can see wispy structures that are very sharply defined all along the edge. But on the inside edge, okay, that material hasn't gotten to that border yet. keep in mind this is in 3D, so this is kind of doing this to you. You can't really tell what side's closer, what's farther away to that edge of the cavity. So it looks really cool. Oh, Leslie, thank you. That's so kind. That's so kind. Thank you so much. Wow, that is very kind of you. Thank you for joining us. I think this is, you know, images like this sort of make it worth it, doesn't it? Right? And while this is still doing its thing, I'm going to go back out here. We did do our all sky cam earlier to see what was going on, and I'm just going to do a quick one again. Okay, maybe not. It seems to take a while to come up, so we have sky. We're fine. Okay. Let me show you what I mean by those those things. So here we go. If we look and we zoom in on these filaments, you can see how they have some definitive edges to them, don't they? Well, that's where that's impacting the interstellar medium at that border. And you might say, well, how come we don't see it in the middle? Well, we don't see it in the middle because of the fact that first of all, it's a spherical expanding shell. And if you look at my fingers, here's the shell facing you. You can see through my fingers. As you get to the edge, you can't see through my fingers. You can't see, so it looks thicker here, kind of like this, right? And, you know, so if it's a spherical shell, it's thicker here, and you're going to see an edge. Here you're going to see less material, but you're going to see material. It's just faint. And then over here, it becomes more again. So in the spherical shell, they tend to look like this ring of material, but they're not a ring of material. Sometimes they shoot off disproportionate amounts toward us and away from us. So this has done that. This particular nebula has done that. And we can see a disproportionate amount when we zoom out, okay, and we look at the fact that there's a central piece here. This all goes down here. The stars literally get in the way, don't they? They literally get in the way of seeing the nebula. I think that's pretty cool. Oh, Leslie, you know, you say it's so beautiful, it makes you cry. You know what? I don't have an ego to bruise. And I can tell you that the first time I saw that sky under this building location, I was standing on a concrete pad and Tara was there during the day, but not at night. I stayed at night. And I was taking photographs on the concrete pad. When I looked up in the sky, all I could do was sit there and cry like a little kid. It was just so beautiful. So beautiful. And I was like, this is exactly what the soul needs. You know, and I don't know if you know this, maybe you do, guys. The night sky is a recognized ecosystem. A dark sky is a recognized ecosystem that's necessary for psychological benefit to people. It's recognized as that and classified as a necessity for human beings. We have all been, living in bright light areas at times. And what happens is you miss so much. You get out of touch with the planet when you're just in your car, or when you're doing this, looking at your phone. We all do that kind of thing. But it's so hard to get people to actually look up into the night sky. So difficult to get people to look up. But I've successful in a way of getting people to look up here. This is just stunning. And if you think that's beautiful, oh gosh, I've got more, but don't worry, there's more. Yeah, it's just amazing. Yeah. Yep. I just find it really interesting that when we're looking at these things, we actually see the object just as it looks like after processing. Okay, this camera system is top notch, and I felt that it was probably the right thing to do because I wanted you to see these things and not have to wait to see them. You used to have to wait for me to process these. No more. No more. Now you can go look at the processed images and just take them, you know. And tomorrow maybe I will try to. Oh, thank you, Leslie. Tomorrow maybe I will figure out how to get that read-only drive up for you guys to get to. Hi, Fantasy. Yes, Antares and M4 was the first object that was showing on the screen when we came in. Yep, I brought us to Antares and M4. Yeah. Now we're looking at the Veil supernova remnant. We've stacked 20 shots. It's auto stacking. And let's go zoom in a little and see what the quality is. See if the noise level is less. I believe it is. Oh yeah, look at. And this is one that can benefit from a little unsharp masking. Watch now. Watch the quality of the nebula now. When I hit unsharp masking, watch how definition changes. Look at that. Every filament is now visible. It's an algorithm that affects things like that, that shows you things like that. Isn't that cool? Yep. And this will not be in the stack. You'll have to add it in if you're going to do it in the stack. If you're going to stack it, if you're going to operate on the stack piece. Okay. I have it now just because we're watching it and looking at it. I just think that's stunning. Oh yeah. Oops, sorry. Okay, we stacked 24 of them. Wow, that's something else. It's so beautiful, yet it belies the absolute chaotic destruction that brought about its very existence. I think that's kind of cool. Its very existence was the largest explosion the universe has to offer practically. There's bigger ones. Isn't that something though? Yes, it is. It almost looks three-dimensional. It almost looks three-dimensional. Isabella, you know what? You've come a long way with the work. Isabella Melamed lives in Sofia, Bulgaria, guys, and what she does is she takes our raw imagery, as I do, and she actually will do her own image processing on it. She's teaching herself how to do it, and I have to say she's doing a really fantastic job. I'm so proud of her. You know, nice job, Isabella. And you know, you don't all have to try image processing, but what you can do is, you know, I know people that actually made these into big giant wall pictures. I even had a dentist's office say, hey, can we make this the size of one of our walls and make wallpaper out of it? And the answer is yes, we can. You know, I mean, you could literally make this beautiful vinyl wall coverings that are actually these, you know, giant, beautiful imagery of the object. It's just stunning, you know. So anyway, it's just something else to do, you know. All right, so this is 28 frames. Look at how beautiful it looks. Okay, and I have to say, I shot this last night. Okay, I did. In other words, I did it again last night, and it didn't look this good. It didn't look this good. I'm really quite pleased. We're going to go to 30 frames and then we'll stop. And we'll move to the other side. And we'll just do a short couple there. Or maybe we'll go to another object that I've been dying to look at. Maybe. Okay, we're going to pause this right here. And now we're going to save it. "16 bits, 30 frames dot fits," which is the file type, and then save exactly as shown. Okay. Let's just, if I click on that, let me just make sure it doesn't show just that middle section. Shouldn't do that. It doesn't. So there's the whole picture right there. Isn't that something? Wow. And you can see all this other stuff here. That's the middle section right there. It's really beautiful. Oh, we're going to get to all that. Not tonight, though. I think we're going to... I said I might make this the last object, but you know what? For people who know me... I can tell you that, as much as I say I'm going to go to bed or whatever... I think they call me Mark Just One More D'Antonio. It's true. I want to do more. I don't want to stop. What can I say? Alright, so I'm going to go back to the 1 second mark here. And I'm going to clear this stack right here. And we're going to go to the new object. And where's that new object? Aha, I thought you'd never ask. And... it's going to be a little further north. And actually, no, it's going to be a little west, I believe. I'll just make sure. Yeah. Okay, so now we're going to go a little less than full speed because we're kind of close to the object already. We're going to go west now. Traveling through Cygnus. And what I'm going to do is... we are in Cygnus the Swan, by the way. That's where the Planetary Nebula is. The Veil Nebula. The Veil Supernova Remnant. Let's do some processing stuff here. I don't want this. Okay, that's better. Okay, and now we come back to Stellarium on this side. And we're actually heading to this guy right here. That's the Crescent Nebula. You'll like the Crescent Nebula too, I'm sure. So, we're going to go a little more north. Yep. And there's two nebulas up here that are really exciting to see. One's the Gamma Cygni Nebula, and they're right next to each other. In fact, we'll probably see a bit of each in these objects. But we'll see. Right now, north is this way. The lines get closer together as you get north toward the north. And let's go up to the crescent, which is... you'll see it show up in the image here. Here the crescent isn't very interesting, but there the crescent is phenomenal. It's an amazing, amazing detailed object. Oh, it would help if I was zoomed out. Maybe it doesn't help if I was zoomed out. Alright, well, let's go back. I might have missed it. Oh, I did. There's too much going on over here. I almost missed it. Okay, I think I gotta go more westward. Yes. Okay. All right, and now northward. Okay, and westward again. Let me just make sure. It's not in here yet. Oh, it is. There it is. Okay. So now what I can do is go and do this. And move it over. The wrong way. This is a cool little nebula. Wait until you see this guy. Because there's way more around it than you even realize. Now we're only doing a 1 second exposure and we're still seeing it. You know, which is really cool. And now we'll raise this up a little bit. Okay. Down and eastward a little bit. No, westward. Duh. Just want to center it. Okay. One more little one. All right. Okay. There we go. Now we can go to 25 seconds. So the constellation of Cygnus, the Swan, is pretty much directly overhead almost. It's close. It's close. So when we look at this here, okay, we are in the Crescent Nebula. And if we look at what's overhead directly right now, let's just bring up those lines. You can see that we are very, very close to being literally directly overhead. That's like a dome overhead. We're just looking straight up, basically. All right, that's an azimuth grid, it's called. If we look at the grid according to the coordinates of like the Earth's latitude and longitude extended into space, then those look like this right here. And that's what we're looking at now. All right, so let's go back. Well, now that we know where we are, let's go back and I'm going to do a live stack on this, and it's going to blow out a little bit. Gotta be careful. We'll clear this, and we're gonna do another stack now. 25 seconds on this beautiful nebula. The crescent is a really interesting object, and I want to show you why. We saw a planetary nebula, which is a slow death of stars about the size like the sun. Oh, look at that. Oh my gosh. And then we saw the supernova remnant, which is stars much more massive than the sun. They just blow up. But then this represents another object, another kind of object. This represents what we call a WR star, a Wolf-Rayet star. Those are very, very hot stars that end up going, they're very massive, and they will eventually go supernova. What happens is they actually end up blowing off outer layers. Okay? In the winter, we look at one object called Thor's helmet, which is beautiful. Isabella did processing on Thor's helmet, which she got from elsewhere, the data. And Thor's helmet shows us a Wolf-Rayet star that's blowing multiple shells off. Well, this is also caused by a Wolf-Rayet star. That Wolf-Rayet star is right in here, somewhere in the middle, blowing this stuff out. It might be actually this star right here. I looked it up to try and find the source of the Wolf-Rayet star for this. But these stars are very, very hot. Nothing can survive around them. They're actually extremely, extremely hot. Okay, but this is unbelievable right here, what I'm looking at. This is beautiful. Now let me undo some of the processing. If I undo this, I don't think it had anything. Yes, it did. Okay, that shows you more of the colors that this thing is. Okay. Okay, and okay. Wow. Unbelievable. It's just a beautiful nebula. And we'll let this come in for a while. Well, you know, I hope you guys enjoy the concept of a live active observatory. You know, because this is just beautiful. Look at the detail in this. My gosh. Wow. Because it's such a large image, it supports zooming in quite a bit. Again, the image is 4144 by 2822 in pixels. Actually, yeah, Fantasy, I actually looked at Saturn yesterday. And the rings were on an angle, yes, but unfortunately, this is a dedicated astronomy camera that we're using here, and this dedicated camera is so sensitive that Saturn blows it out, you know. And maybe I can monkey with the settings and maybe get it back and maybe get it to look good, but so far Saturn doesn't look very impressive yet, because I have to get a shorter exposure, and it doesn't want to do a shorter exposure. Isn't this beautiful? Look at that. Again, it's a Wolf-Rayet star, very, very hot star. You know, 50,000 Kelvin and sometimes higher, and blowing off its outer layers. Over here, you can see the telescope pointing up, almost straight up. Wow. Oh yeah. I don't have any words, guys, because this has turned out to be just such a stunning night, you know. This is really stunning. This might be a little much, but I want to see. Look at that. Wow. Look at all the dark lanes in this material here. Look at all the stuff, all the debris and litter that's in this galaxy. Look at this. Isn't that amazing? Oh. Wow. I don't know. I just don't know what to say sometimes, you know. Sometimes there's no words. This is one of those moments. This is absolutely rich and gorgeous. Wow. We're going to be here a few minutes. Let's just maximize this. There's got to be tools for showing things full screen. I don't know if that's it. Yeah, no, not it. But man, that's just hoo-ah. I just don't know what else to say. I mean, what else is there to say? Stunning? Beautiful? It's a beautiful thing there, you know? Wow. Okay, we've got 17 down. Look at the colors coming in. You see how these colors are getting more vibrant as it goes? So that's the beauty of the stacking process. It adds signal and gets rid of noise. Look at that. Amazing what's up there, huh? You know, I could keep my astronomer's hat on and say, wow, that's a Wolf-Rayet star nebula. That's pretty cool. And look at these diffuse hydrogen nebulae and these dark lanes made of carbon-carbon bonded atoms of molecules. I can say that. Or I can say, this is stunning. Look at all those stars. It's glittering jewel boxes. Punctuated with these beautiful red curtains of amazing material. Because that's what it looks like. Did you ever see so many stars that you almost can't recognize what you're looking at? You know? Yeah, fantasy, that's true. I'm certainly not going to make you wait for 8 hours. But you know what happens? What he does is does like 2 hours a night on one object, 2 hours on another, 2 hours on another. And over time, he puts those all together. We can do the same thing. We can go back to this and do a stack of this again. You know, like we have 21. And it actually tells you... If you look on the lower left here, let me get my face out of here. I'll come over here where I can have a little more room. Hi there. Okay. So down here on the lower left, right down there, okay, you can see that it says frame stacked 22, frames ignored 0, total exposure 8 minutes 10 seconds. So 22 frames, 23 frames now. And it's only 8 minutes 35 seconds, 9 minutes 35 seconds of time that we've exposed this. And stacking a bunch of short exposures leads to a better result than trying to do one, big long exposures. I did that before. I actually worked on one exposure for 1 hour and 45 minutes in a major observatory. And I didn't want to lose my ability to take the picture, so I was sitting on a ladder at the top of the telescope and didn't notice that this giant metal ladder, which was a large staircase ladder with vertical posts and everything, was getting slowly bent in by the telescope. As the telescope was following the sky, I'm guiding the telescope to make sure it stays on target. And as I did that, I actually got literally closed in by the ladder, which bent around me and sealed me in. And I didn't notice it because it happened in slow motion. So it was like a steel Venus flytrap for people. You know? Needless to say, I can tell you that they weren't too happy with me at the observatory for that. But I did do good work, so I wasn't penalized for it. Oh my gosh, look at this. This is so utterly gorgeous. I mean, look at that. I mean, that's like, I can't. I mean, look at the you can see these striated areas. It looks like pleats and curtains, okay, of this gas. It's beautiful. Wow. Wow, that's incredible. Here's an interesting little feature to show you right here. You notice how there's a little gap down here with a little purple weirdness here? That's because when it started stacking, the telescope is drifting a little bit, and there's a guider that's guiding it to keep it on. But as it's guiding it, sometimes the field gets off a little bit and it stacks, and so it stacks in a way that this doesn't get added in, or it didn't have enough data to finish the stack in this direction. So what I'll do is I will literally just cut that off. I'll crop that out later. I'm going to go to 30 and then stop. I just cannot believe what I'm looking at. This is absolutely, utterly amazing. And there's 30. And now, before anything else, I'm going to save this stack. Save as 16-bit 30 frames, 750S fits is the name. And I'll save it exactly as seen. Now, the first images of the night are already up in the cloud. The observatory ships all the stuff I take out of the desert up to the cloud so that I have it all ready to go. So the first images will be up there. But because I did so many tonight, it's probably going to take several hours for all this information to get shipped up to the cloud. So I'm just happy that you guys were able to come along and see this. Really cool. All right, so now, wow. Okay. So now I am going to close up for the evening. I'm sorry. I want to go longer, but it's after 3 a.m. here, and I'm starting to talk funny. I can feel it. So I will be taking my leave of you, and I will be back on the next clear night, which could be tomorrow. Yes, indeed. I do this every night if I can. All right, so this guy is done, and okay, and now what I want to do now is the telescope is way up high, and I just need to park the telescope now. And so to park the telescope, I gotta bring this over here. I gotta make sure it has the same park position it had before. All right, so parking the telescope is simple. What we do is we just hit park, and the telescope goes and parks itself. And it knows where to park because I told it where to go. But I'm really not. I'm comfortable, but not comfortable. It should know what to do. So I haven't had to redo anything, so I think it should know. Scary. Okay, we're going to try it. Hopefully it won't hurt anything. Okay, so the telescope's now going to go moving around. Comes down to a somewhat horizontal position. and then it parks, and it should stop right around there, and it is. And then this thing here now says the scope is parked. I can turn off the telescope. That's the last thing I do. The first thing I do, next thing I do, you're going to see it all. I'm going to show you everything. And I will actually, I'll make this bigger so you can see it. Again, slow out there. So grabbing things and expanding corners of windows doesn't always work at the same speed. So you have to bear with me on this. Okay. I'll do that in a second. Okay. Now, what I do is I have to disconnect the scope. So I'm going to disconnect it. And telescope is disconnected. And I will exit from our control program. There's a whole process to go through. And then I get rid of this, and then I disconnect our planetarium connecting program and exit from that. Daisy and Zoe, you're funny. Sleep till noon, but sleep till noon. Yeah, well, you know what? I normally get up around 8:30, 9 o'clock, and it'll be the same for tomorrow as well. I only get about 4 to 6 hours, and that's really all I need. I'm so anxious to do the processing that, I have to, force myself to just, actually eat breakfast, because I don't always. Yeesh. Okay, so this guy, that's the telescope view with the infrared, and now what I'll do is bring up the system here. Okay, all right, now the handset, I'm going to turn the telescope off right now, and to turn the telescope off, the telescope's going to go off because you'll see the handset here, and then I'm going to now turn off the telescope power. I wrote a program to control my observatory. I mean, you could buy programs that do it and stuff, but I just did it myself with Arduino. It's so easy. So, okay, that sounded arrogant. That's not what I meant, please. What I meant was, I used to be a computer programmer, so this was something that was easier for me to kind of leap into. And for the record, I wasn't that very good at it, so, so there. Okay, so now we turn the power off. You'll see the power go off here. All right, telescope is off. And now the only thing left to do is to close the roof, because we don't want rain getting in. We've had violent rain out there, major thunderstorms at some points. Believe it or not, the desert does get water. So here we go, closing the roof. Here it comes. 2,500 miles away, the roof closes. Yep. When we get the faster internet, that's going to be one fluid motion. You won't be able to detect anything. There won't be any lag time. It'll be like you're sitting there watching a movie. It'll be as quick as that. So there we go, guys. The observatory is closed for the evening. And I have a bunch of imagery to make sure I get up to the cloud. Well, it's going to send it up. And then I'm going to take that imagery and make it available to all of you. I really enjoyed your company tonight. Thank you, guys. And we'll do this again real soon. And that, like I said, real soon could be as soon as tomorrow. And we'll do some more cool things. I can't wait to see how these are all going to come out. These are so cool. Wow. Oh, I'm so excited. And the only thing keeping me from doing it tonight is the fact that they're not all uploaded yet. I got to wait for it all to get uploaded. So, I will talk to you guys, on the next clear night. And thank you guys so much thank you for your contributions. Thank you to Keith for his contribution, and thank you to Leslie and others who have been here and contributing. It's been so amazing. I think you guys were amazing, and I appreciate you wholeheartedly. If you have any questions about this type of stuff, what we're doing, the cameras, the actual objects that we're looking at, you can feel free to ask. I'm easily found on Facebook, so friend me, join SkyTour LiveStream, and give me the thumbs up, would you? Because I want to make them notice it so that I can get farther along. We're just over 5,000 subscribers, and I'd like to go to 50,000. That's not too much to ask, is it? Maybe. I don't know. In any case, you guys have a good night, and I will talk to you later.